to the usefulness of the satellite products, starting with the launching of the satellites, development of satellite tools and technology, various application programs, and hence its validations and utilization from time to time. We have been continuously becoming knowledgeable, but there was a need to evaluate ourselves, to evaluate the tools and technology, to evaluate the application of satellites in the monitoring, predictions, early warning services in the globe. So that process, which started in 2010, has certainly enabled us to adopt a standard practice of monitoring evaluation of the satellite products and its usefulness. And certainly that process has helped us to develop many user-oriented products. So I thank on this occasion the entire satellite community from India, Europe, USA, Japan, Korea, China, and many others. We have really developed the satellites for the benefit of the satellite users. I also compliment and congratulate all the satellite users, those who have made the satellite useful, those who have made the assimilation of the satellite data and products in the process of weather monitoring and forecasting, in the process of numerical weather prediction modeling. And finally, it has been able, with all of your support and cooperation, to utilize satellite products in all processes, be it hydrological process or agricultural process, or be it disaster risk reductions, or be it the air quality or the environmental protections. So everywhere you can find the presence of the satellite applications. And I am sure this conference, what we are organizing today with the help of many of you, including WMO, space agencies, and of course, various countries participating in Asia-Oceania Meteorological Satellite Users Conference. I also thank the CGMS, Coordinated Group of Meteorological Satellites, which has helped to exchange the data and information among the countries and reach out to each and every person in the globe. So I am sure with 3 days deliberations, we'll come up again by identifying the gap areas, by identifying the usefulness of the current practices and current products, and also planning for the future requirements. I am happy to inform you that this conference has been preceded by 2 days training workshop on yesterday and day before yesterday. Many people from this group also participated in this training workshop. I thank all the instructors who participated and provided knowledge, experience, and expertise in this process. Again, it will be followed up by a management meeting, that is interactive meeting of the RA2 and RA5 in this region, which covers Asia-Oceania. That will help again in policy, planning, and implementation of various schemes in this region for better utilization of satellite products and applications. So I will not speak more. We will wait for the formal inauguration around 12:30 today, as has been told by Mr. Sai Krishnan. So thank you very much for your august presence here and cooperation for organizing this event. Thank you very much.
Thank you, sir, for your kind words. Now, I would like to invite Dr. Alan Huang to kindly brief the gathering.
Thank you. Good morning, ladies and gentlemen, distinguished guests, friends. I always want to share with you, we are friends. We share the same earth. Okay, so we have this fortunate opportunity to get together. It's my honor. So I'd like to provide my best service to you, bridging your gaps to the knowledge we know, to the beautiful locations, to the IMD that put so much effort into this third rotation, hosting first time in third rotation of LMSUC ALMSUC is hosted by 7 countries under the WMO coordinations. So WMO have this beautiful ideas that these sectors, we need to come together to solve the same problem, the weather. The weather has no boundary. So we don't have political boundary. We are all here to benefiting the mankind by preparing ourselves for a better tomorrow, overcoming all the weather adversities upon us. Weather is more intense, more extreme than everybody know about it. So LMSUC serve the most important form to combine the hosts, including China, Japan, South Korea, Russian Federations, Indonesia, Bureau of Meteorology, and India, serving the anchor points for the focal points every single year. This is 14 times we have been doing since 2016 under WMO coordination, the permanent representative of your weather leaderships sign agreements to commit itself to come together to bring the resources, bring the manpower that you have, bring the service you are serving your country together, solving your problem, using the common global observation those agencies put up. But it's not limited to these sectors. Our colleagues from the United States, from Europe, are also joining, as you will see. They are contributing their space programs. Europeans have contributed the METOPS and other geostationary measurements. United States contribute JPSS, NOAA satellite series, or other GOES satellite series in the sector of the west side of the Pacific Oceans. All these are resources for you to use. I can promise you, committed to you, these 7 countries, willing to share all the data to help you. So any request, anything you learn today that you are not happy or you want to have more innovations into it, they are willing to improve it. And through WMO's Regional 2, Regional 5 coordination meeting, you have chance to report your concerns, your efforts, anything else you want. Making a request through the coordination meeting, through WMO meticulously record and promotions, your voice will be heard. So despite of in this meeting, we are going to get technical. Some are technical. So we have technical information exchange, talk about theory, algorithm, and remember Professor Nakashima will tell us all cloud physics theory behind getting the best cloud products. It's by no means easy. It's scientific difficulty. But some of you use as a product. You just appreciate those sophistications. But you don't need to go really into it because we have another group of people doing this. But you need to use it, knowing its pros and cons, deficiencies, and then you can use it with confidence. So I like to thank IMD again, provide such an excellent infrastructure, allow us to freely talk about what we need to coordinate with each other, and don't be shy to stop anyone, ask them anything that you need. Again, we are here together through this collaboration, through WMO leaderships, coordinate. We want to have everything for all, including disaster for all, and that WMO is concentrating on. So today, it's my honor and privilege to working with you. Let's come together to harness all those great power and the hospitality offered by IMD. Let's go for it, get whatever we need, and when you go home, you are loaded with information, loaded with space knowledge to help your local colleague to do a better job for protecting and benefiting our mankind. Thank you so much. Thank you.
Thank you so much, sir, for your inspiring words. Sir has been here with us for the past 2 days, and he's been enlightening us for the past 2 days continuously, and will keep doing so for the next few days too. Now, I would like to invite Dr. Krishna Mishra. He's a senior scientist at India Meteorological Department. He has extensive experience in weather forecasting. Sir, I invite you to come to the stage and kindly provide us with weather briefing.
Yes, thank you. Thank you for your patience. So currently, if we look over the entire country, so there is almost dry weather going on. But we had, as we all know, that there was a cyclonic storm which crossed near Puducherry of southern state of India, Tamil Nadu, uh, with a wind speed of 70 to 80 kmph. So that cyclonic storm crossed the southern peninsular India and it emerged into the Arabian Sea. And now it is lying as a well-marked low pressure area over East Central Arabian Sea, adjoining coastal Karnataka as a well-marked low pressure area. And if we look it into the satellite picture, so currently we can see just a very moderate type of convection, moderate to intense convection over this to the northwest of Lakshadweep. And this well-marked low pressure area is likely to become a low pressure area during next 12 hours. And thereafter, it would further weaken. So as we can see, there is no impact currently over the mainland of India due to this well-marked low pressure area. And then, so till yesterday, there was extremely heavy rainfall over the southern peninsular India. And today onwards, as we can see that there is no likelihood of any heavy rainfall warning over the country. So this is the rainfall distribution. and rainfall and all other severe weather warning maps right from today up to next 7 days, that is up to 10th of December. So as you can see, these are the maps: 7 December, 8 December, 9th December, and 10th of December. So there is no weather warning in terms of either neither the heavy rainfall or in terms of the, as DGM sir said in his inaugural address, that nor in terms of dense fog over the northwest India. So we are not getting any dense fog. We just observed 2 spells of dense fog over the northwest Indian plains, and that was on 13th of November and towards the end of November, that is 28th of November. So now another weather feature we are seeing, that is the jet speed winds of the order of 120 knots over northwest India plains, and there is a feeble cyclonic circulation over in lower tropospheric levels over Bangladesh. So now next 7 days, as we saw that it is going to be warning free, although we are expecting as we can see here, that in this table we can see that towards this 7th December, we can see there is isolated rainfall distribution. It is showing that is the subdivisions are likely to receive over about 1/4 area of the subdivision rainfall activity, that too just very light to light rainfall over the plains of Punjab and Haryana, and light to very light snowfall over the J&K and HP. And this too is in fact not being supported by all the weather numerical weather models. This is being supported mainly by the ECMWF model, which we always give weightage to, and that's why we are expecting the light rainfall and snowfall over the Western Himalayan region, that is J&K, HP, and Uttarakhand, and isolated light rainfall activity over extreme northern parts of Haryana and Punjab. So till then, we are expecting that the weather would remain dry, as we have been forecasting since last 4 to 5 days, that there would be no dense fog, and there would be not even shallow fog. We have started. We have removed from our fog warning, and it will be clear weather. Okay, thank you.
Thank you so much, Dr. Krishna, for the weather briefing. It's an honor to introduce Dr. Takashai Nakajima. Sir is professor at Tokai University. He received his Doctor of Science in Earth and Planetary Physics from University of Tokyo in 2002. He began working at Japan Aerospace Exploration Agency in 1994 and moved to Tokai University in 2005. From 2004 to 2006, he was an invited associate professor at the Center for Environmental Remote Sensing. And from 2008 to 2009, he served as a visiting scientist at Colorado State University. His current research focuses on the remote sensing of clouds and aerosols using visible and infrared multispectral radiometers from space and the theory of light scattering by non-spherical particles. He is also a principal investigator for both the EarthCARE and GCOM-C missions of Japan Aerospace Exploration Agency. I invite you, sir, to kindly deliver a keynote speech on satellite meteorology.
Okay, thank you very much. Good morning, everyone. My name is Takashi Nakajima from Tokai University. Tokai University is a kind of private university in Japan, a very large university. And today I'm going to talk about investigation of the cloud evolution process. cloud evolution process is very important to understanding our nature process for new satellites. Okay. Okay. This introduction to cloud exact and important influence on the water and energy balances. There's more observation required for understanding of a cloud life cycle. For example, Landau papers pointed out a mere 4% increase of Earth's area covered by low-level cloud, low-level thick cloud, compensates for a projected 2 to 3 Kelvin rise in global temperature due to a doubling of carbon dioxide. And we have long history of the passive sensing of cloud and using the NOAA, ADIOS-2, FLIN, Aqua, and the geosynchronous satellite, the very famous one, famous family of satellite. And recently, active sensing opens a door toward a better understanding of cloud in terms of cloud evolution process. Okay. Today's content is first the statistic global distribution of cloud and aerosol properties. And second, the current state of a novel satellite pitch cloud radar, the EarthCARE. Okay, with cloud radar, the EarthCARE. And the third, new visualization method of the radar reflectivity, the CFOD, a synergistic use of passively retrieved cloud property. And summary. Okay, let me show the first view graph. This view graph is cloud optical thickness, effective particle radius, and aerosol optical thickness global distribution for 1 month average of data. And this is statistic, okay? And here, the east coast of Asia, covered by the large AOT. And at that time, the cloud droplet radius, cloud droplet is a small particle, and they have like the 10 micrometer radius, but of course, there are large particle and small particle. And large aerosol thickness areas is just at the small particle size area. This is natural, yeah. And large optical thickness. This is the kind of first kind, the aerosol first kind effect, indirect effect. Indirect effect aerosol of a first kind is, for example, the left panel shows the pristine environment. The cloud particles tend to be large because the cloud condensation nuclei, the CCN is aerosol, the CC low aerosol environment, the particles tend to have this large effective radius. However, in the turbid environment like this, there are many CCN, the cloud condensation nuclei, and the cloud particles become very small. That is because this area, the cloud drop radius becomes smaller, just the area of large optical thickness. Okay. And what about volcano? Yes, the volcano can provide us the CCN. And this is an example of volcano eruption. This view graph is here is the Pacific Ocean, the United States and Asia. And we can find here is the Hawaii Island, okay? Okay, in August 2007, the 1 month average of cloud effective particle radius. Here is the large cloud effective radius area, and around the Hawaii Island, yes, cloud effective particle radius is still large. However, during the eruption of Mount Kilauea at the Hawaii Island, and the wind direction is like this, okay? That means the smaller particle area appear. Yes, the smaller particle area is length of 5,000 kilometers and 10,000 kilometers, very large area. Due to the CCN supply to make the cloud particle size small. This is the first kind of aerosol indirect flight and indirect effect. Anyway, the direction of the cloud research is the long-term record is still very important for the climate change studies. For example, starting from ABHRR and MORIS and Global Imager and SGLI and ZCOMC HGLI, and we also, of course, we will continue to use the suitable satellite or sensor to continue the climate change study longer than 10 or 20 years. And the second one is the three-dimensional observation of the cloud evolution processes and CloudSat plus Calypso and the EarthCARE, just launched the EarthCARE, plus the passive sensor. The synergistic use of the active and the passive sensor makes the cloud evolution process very clear. And observation plus the model simulation will make more better understanding of our cloud evolution process. Would you please click here? The movie will start. Click here. Can you make a click here? Yeah, movie start. Yes, thank you so much. Okay. This is model simulated cloud evolution process. This is not observation, but model simulation. Amazing. Okay. And the cloud started to evolve from the CCN and become the cloud drop radius and can become the drizzle particle, larger than the cloud particle, and become rain. This is the life cycle of cloud. Maybe 30 minutes to one hour life cycle of cloud. Okay. And the EarthCARE has just launched in this year, the launch in May 2024. It has cloud profiling radar CPR and multispectral imager MSI and high spectral resolution LiDAR at Italy and the broadband radiometer BBR. It has 4 sensors. Okay, this is EarthCARE. And why we make the particle profiling by using the EarthCARE, the particle profiling the radar. This is the birthday cake, and EarthCARE try to infer the inside of the crystal, okay, happy birthday cake, and cut. Okay, very clearly. We can find the inside of the cloud very clearly. This is just what we want to do, okay? Okay. Anyway, the EarthCARE, the launch, okay, time the May 28th, 2024, at night at UTC, and the rocket of the Falcon 9 is SpaceX, and the launching site at the Vandenberg launching pad at the United States. And this is during the launching of the EarthCARE, and just separate the EarthCARE from the launching vehicle, the rocket. Okay. And this is the first image of the MSI sensor. One is also storm for the west lawn. Here, the storm. This is big. And the MSI sensor, a little bit narrower to us, but it has 500 kilometer. It has 500 kilometer spatial resolution. This figure is very fine and beautiful. The another one is orographic cloud over northern Killary Island. Yeah, very strange cloud appeared in Killary Island, and we can find the two-dimensional. Yeah, this is the traditional sensor, the passive sensor. EarthCARE also has a passive sensor as well as the cloud radar. And this is the first image of sensor energy, synergy. This area is MSI image captured by the MSI of the EarthCARE. And this is the particle structure of cloud. Here is the rain band, melting band, and the upper part is the cloud particle, lower particle is the rain particle. Okay, could you please play the first movie? Thank you. Yeah, interrupt PowerPoint and play the first movie. The MP4 file in the. Yes, it is okay. Okay, this is the image of the EarthCARE. The story of the EarthCARE. No sound. No sound with sound. This movie has sound. Okay, thank you. But I forget to say that the EarthCARE project is the JAXA and the European certificate. Yeah. Okay. Another one, could you please play another movie? The first synergy result, another movie. Yeah, another movie. You cannot play another MP4. Yes, please. No sound. No sound. Thank you. This is the first image of the EarthCARE. This is real data. The cross section, the particle profile of the cloud structure. And here is a melting band, and below here, the rain falling, and upper there, a little bit larger particle, and here is the smaller particle cloud. And the EarthCARE CPR has the Doppler capability function, we can observe the particle velocity, the vertical velocity. This is falling down. Okay, this is here is falling. Here is unstable, and here is the upper draft. After updrafting, this is the newest function. The ClassSat doesn't have the Doppler function. The EarthCARE is the first satellite it has the Doppler. Okay, thank you very much. Could you please come back to the PowerPoint file again? Yeah, could you please come back to the PowerPoint file again? PowerPoint file again. Yeah. Yes. Yes, I will control. Maybe from 15. Okay, good. Thank you so much. Okay. Because EarthCARE data will be released, the level 1 data will be released in January, next January, and level 2 data will be released in the next March. I cannot show the result of the EarthCARE more in detail, unfortunately. However, we did the similar result using cloud radars, the CloudSat, and Imager for Aqua. The couple use of the two satellites is similar to the EarthCARE, okay? And this is the view graph to the seaport. The seaport, this is the 8-lane cloud direction, and the modest retrieve effect particle radius for the 8-lane flight direction, and the modest retrieve cloud optical thickness, and the CloudSat retrieve the radar reflectivity. Gathering the data, long-term data, for example, 1 year or 2 years or several months, gathering the data, we can generate this kind of view graph. This is called seaport. Okay, the vertical axis in cloud optical depth, 0.0 means the cloud top, and here is cloud bottom. And the horizontal axis is radar reflectivity, small radar reflectivity, large radar reflectivity. And small radar reflectivity corresponds to the small particle size, and the moderate radar reflectivity, the drizzle particle size, larger than cloud particle. And here, the rain particle more. And this is a static analysis of two-dimensional PDF, and a case of 14 micrometer to 60 micrometer of modest retrieve cloud effective radius, grouping by the modest retrieve cloud effective particle radius. This chart is very useful to follow the cloud evolution process because, for example, the small particle size area, the most of the particle gathering in the left part of the seaport, it means the cloud particle gathering here. Okay, this is the condensation mode and the collision mode, the transit to drizzle at the middle of part of the cloud. And the coalescence mode, the particle become rain. This is a statistically appeared cloud life cycle. Okay, this is very clear. And again, here is the cloud evolution process. And next one is here is the transit to drizzle and become rain. Okay. And we generate the seaport by using global land area seaport and global ocean area seaport. Very big difference between global land area and ocean area because different environment, atmospheric aerosol environment and dynamics difference. Okay. And my students examined the three regions: Californian, East Asian, and the Peruvian. The seaport quite different because of the different environment of aerosol and dynamics. Evolution process is quite different. It's very interesting with that. And also, our PhD candidate students do Thailand, around the Thailand seaport, during the El Nino event, the more rain in Thailand. El Nino event seaport and La Nina event seaport for the more rain in Thailand, and El Nino event seaport less rain in Thailand. Very big difference we can find. To understanding the evolution process for each area or each season, the seaport is very useful to understand the cloud evolution process. Okay, and the strategy of the cloud observation is we are going to use the two-dimensional observation by using imaging sensor like GCOMC SGLI sensor, and also the EarthCARE for observing the vertical profile, and beam method model comparing the cloud evolution process, the beam method model, and also the global GCM, global covering model. This is our strategy for cloud evolution process understanding. Okay, and also the pricing. Okay, we are using 3.7 micrometer and 2.1 micrometer and 1.6 micrometer from imaging sensor like Himawari. We can retrieve effect particle radius, cloud particle radius by using different wavelengths. And different optical effective particle radius is obtained. This is one of the miracle, uncertainty, and we didn't understand this for long years. But we are thinking about the 3.7 micrometer cannot penetrate inside of cloud. That's because 3.7 micrometer has information of cloud of particle size. And 2.1 micrometer has a moderate part of cloud size. And 1.6 micrometer is a deeper area of cloud particle size. This means using a passive sensor, we can slicing the particle slicing of cloud structure by using passive sensor, not active sensor. This is the very interesting feature. Okay, the summary. Need more observation of cloud from satellite for generating cloud climatology database, investigating cloud evolution process. The seaport new visualization method presents cloud evolution process very clearly. Results are consistent with the past studies by Trim, Ariostu, and Morris, and useful model evaluation. A Doppler capability of the EarthCARE CPR cloud profiling radar improves our understanding of cloud evolution process. And of course, third generation and next generation geostation satellite will observe time series of cloud evolution. Okay, seaport is not a time series, but statistical analysis. Very important to compare with the seaport and time series of cloud evolution process by using the geostation satellite, because geostation satellite has a time step of 2.5 minutes to 10 minutes, very fine temporal resolution. Okay. Thank you very much. That's all my talk. Thank you. Thank you.
Thank you, sir. It is a wonderful keynote address by Professor Nakajima. Now it is a question and answer session. I request participant, if you have a question, please ask. Particularly, if I can say, yes, I have been very good information that we received, that now sounder information from cloud properties, that slide, I think that is required, because droplet size of the particle is now, it is to be required worldwide with the growing pollution and emission of carbon emissions and all. So now I'll ask if anybody have any question, please. Sir, Ellen, sir. Sir.
Thank you, Professor Nakajima. You are using near IR, shortwave IR, and radar data, combined passive and active. There are a lot of other information contents from microwave channels, especially this multiple scattering signals from high frequency provide additional information contents. And currently we fly the AMSU, ATMS sounder data. They have 18 channels, 22 channels, data sets. So in combination with those microwave, how you can foresee this type of data may help you to see the microphysical property of it despite of low resolution microwave sensor?
Yeah, good question. Okay, the combination of passive image and microwave image
Okay.
is very important to use. Of course, the vertical slicing of cloud,
Yeah.
because the microwave has penetrated the cloud
Mhm.
entirely the cloud layer.
Mhm.
But the optical sensor have the information of the cloud tops.
Mhm.
The contrast between the microwave and the optical sensor make the vertical slicing of cloud.
Okay.
This is one idea.
Okay.
Yeah, very important to use. But yeah, I mean, you know, the spatial resolution is quite different between the microwave and passive imaging sensor.
Yeah.
Imaging sensor had finer
Yeah.
and the microwave very large.
Right.
Very
Yeah.
large. And the combination is a little bit, yeah,
It's not easy, but yeah.
Yeah.
So, but the new generation microwave sounding data will evolutionize our capability of it. So yesterday, the Secretary of Minister of the Science, he called for our ingenuity to come up with cloud resolving, cloud penetrating capability so that we can safeguard the Indian regions of severe weather, tropical cyclone, and everything else.
Yeah.
And so he is visions. We should collectively think about how we answer his request. So one way is, along with JAXA and others, they have a new generation of satellite system in microwave, providing kilometer resolution, not just 20, 30 kilometer resolutions with high temporal frequency, using CubeSat technology, using high frequency at 180 gigahertz, 300 gigahertz at highest possible resolution with rapid refresh of 10, 15 minutes, flying formations in combination of low Earth orbits, in combination of highly elliptical orbits, flying priority. Maybe we don't need to fly everything on oceanic area, but over the Indian or Indian continent regions, so that we have priority targeting certain area, have highest frequencies, and the other area have a gap, so we don't care, so that we might have opportunity. So, Professor Nakajima, we are counting on you to lead us to find ways to use more data, using more microwave data. Hopefully, we can address this cloud physical property so that data simulation and everything else can be better to predict the thunderstorm that we still very short of. Thank you so much.
Thank you so much.
Thank you, sir. If anybody. Just your name and your organization name also,
Oh,
please.
sure, sir. Good morning, sir. I am Arundhati. I am from Northeastern Space Application Center. So my question is regarding your presentation. In one slide, we saw that over Thailand during La Nina and El Nino event, the cloud evolution process is quite different, right?
Yeah.
So is it because of the large scale availability of moisture, or maybe how the large scale is influencing the convection that is like causing this, or is there anything else? Like, is there any cloud aerosol interaction, different type of cloud aerosol interaction is being placed during these two different environments?
Okay, the contrast between the land and the ocean is very, very important. We found that, yeah, we are very surprised to find this difference. And one difference is, okay, convection process is quite different between the land area and the ocean area first. And another one is the over land. There are many kinds of cloud evolution process comparing with the ocean. Ocean is very monotonically very simple. The evolution process of the ocean over ocean is very simple, but over the shift is quite different between the land and the ocean area. And also maybe the aerosol environment is different between them.
Okay. But sir, my question is particular to that El Nino and La Nina condition over Thailand. So the
Of
place is
Thailand, right.
constant. The place is constant. Now the environmental condition is different, right? One La Nina and another one is El Nino.
Yeah, okay. The
So-
Thailand analysis is very difficult. It was a very difficult task for us to Thailand because El Nino and La Nina difference is not so big difference. Yet we can find a difference, but maybe before starting analysis, we considered more big difference appeared between the El Nino and La Nina, but difference are a little bit small. Maybe basically the cloud evolution process is the same, but a little bit something key factor will change the evolution process of the La Nina and El Nino in Thailand.
Okay.
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 Thank
sir.
you.
Thank you.
Thank you.
I have a
If you have-
question.
Okay.
I have a
Last question.
question. When we are relating these cloud features in terms of cloud effective radius with different kinds of environment, that is a polluted environment and a pristine environment, then is it a good idea to relate directly to the aerosol environment with this cloud effective radius without considering the cloud liquid water path?
Cloud
As-
water pass?
Because we are not considering the Taumi effect in that case.
Cloud water pass, okay. Okay, the cloud liquid water pass can be calculated by okay, cloud optical thickness multiplied by the effective particle radius.
Yes.
And also, it can be obtained by the microwave imager as well. Yes, cloud water pass is very important factor for how large the water droplet are included in the cloud, very important. And yes, the EarthCARE is a very nice sensor because it has the particle slicing. And of course, the hydrometer location is quite different between the cloud top and cloud middle and the cloud bottom. But the EarthCARE and the CloudSat can make slicing and make them very clear. And okay, we great effort trying to analyze the cloud liquid water path.
Because without considering the cloud liquid water path, we can't directly relate this aerosol environment with the cloud effective radius.
Yeah, sorry, I don't understand.
We may discuss.
Okay, we will
in the during
discuss.
coffee break. Yeah. Thank you, sir.
Thank you.
Thank you, sir.
So now I am going to the second keynote speaker. It is none other than a satellite meteorologist. When we joined IMD in almost 2 decades back, Shri R.C. Bhatia ji, ADGM, retired.
Mr. R.C. Bhatia did his master's in physics from Delhi University. Sir joined IMD in 1972 and retired from IMD in 2008 as Additional Director General of Meteorology after 36 years of glorious service. Sir underwent a special training in satellite meteorology in France and played a crucial role in laying foundation of INSAT program, which started in 1982 and has been developing since then. Sir continues to be a guiding light and takes training sessions at IMD at the organization's request. I invite Sir to kindly come to the stage and deliver your keynote address on Western disturbance monitoring with satellite-derived products.
Good morning. I'm going to structure my presentation in 3 parts. First, I will be talking about in general what WDs are. Very brief, of course. I know everybody is aware of WDs. And then is forecasting aspects, what is important for WDs. And third is a few specific cases where the products from space-based system have proved to be very useful for monitoring and analysis of Western disturbances. So my first part starts with very brief introduction. They are baroclinic upper tropospheric systems that travel eastward along the subtropical jet in the northern hemisphere and have a positive vorticity anomaly that extends through much of the troposphere with a maximum at 350 HPA. And they are associated with surface low pressure system. Most common during winter months, December to March. And they are important because they are associated with with weather hazards of various types, heavy rain, snowfall, and so on. And they are very crucial component of water security of Indus and Ganges river basin. About 45 to 65 we get per year WD, out of which 15 to 25 are active. And the dominant role of Arabian Sea as a moisture source for the WD that has been proven very recently through some research work. And we get extreme rainfall typically produced through interaction with elements of WD. And I will be showing an example of this system, interaction of westerly trough with the monsoon system. And if you see any picture, this is how it appears, western disturbance. You can see here over northern parts of the country, series of them moving one after the other. For this very simplistic view, sometimes it can be more complicated. And water vapor image, you can see the jet also in the water vapor image. And just a very quick review of past studies. One of the best papers is, by Dr. Dhimri in 2015, and he has reviewed right from the beginning the evolution of scientific understanding of WD, and his paper of 2015 is very well quoted many times. And this is one of the best papers. And then another by Dr. Hunt of Reading University, UK in 2018. And here is the most recent paper, which is about to come or is coming in 2 days about Western. So this is a second review, update of what Dr. Dhimri did in 2015. Next review is coming within next few days. In fact, it is available on the ResearchGate and website of University of Reading, UK, the most recent paper 2024. And of course, there are other satellite-based studies right from the beginning, and they categorize the Western disturbance based on satellite pictures. And these are referred in the work by Dr. Dhimri, which I mentioned a few minutes ago. And there are some other small studies by scientists of IMD in 89, 92, and 2009. And of course, from Hunt et al. 2018, he has actually applied a tracking algorithm to the upper tropospheric vorticity field for using 37 years of data. And he has categorized, he has prepared catalog more than 3,000 events and talked about structure in brief, which is warm over cold, dry over moist structure, and strong northwestward tilt with height, strong ascent ahead of the center. These are the standard characteristics of a Western disturbance. And of course, this is a diagram taken from the paper which I just now mentioned, that the genesis density is shown here. Sorry. Genesis density per year per 100 square kilometer in this color, and track point density, which is shown with this. And you can see that the maximum tracks are over the Indian region. Wherever they generate, they get genesis. The tracks merge towards India, as you can see from this diagram. Now, it's a definition of WD. It's a very fundamental definition for IMD also adopts. It's a cyclonic circulation trough in mid-tropospheric westerlies, and Actually, it occurs in mid-latitude westerlies and originates over Mediterranean Sea, Caspian Sea, Black Sea, and move eastward across North India. And there are upper-level synoptic scale vertical perturbations embedded in the subtropical westerly jet associated with extreme rainfall events in North India, Pakistan during winter. And the conceptual diagram of this WD is shown here. In fact, it is copied from the paper of Dr. Hunt's most recent paper, which I referred to a few minutes ago. And you can see the subtropical jet, the streak, the verticity embedded in this and traveling eastward, the descent behind cold air advection, warm advection, moisture flux, and ascent ahead of the system, where you get a lot of rainfall because of orography interaction. This is just a copy from full credit goes to nothing mine in this diagram. And see, based on the most recent work which I mentioned just now, Dr. Hunt has proposed a new definition of the Western disturbances, which I have produced here. They are eastward traveling upper level trough passing over South Asia that rise the instability on the jet are on the jet as extratropical potential verticity cutoff. So he is including these cutoff systems also. He has proposed cutoff system also to be included as Western disturbance. And he has mentioned that the moisture they draw primarily from the Arabian Sea, because earlier understanding was that they bring their own moisture from Mediterranean and the other parts, but he has done very extensive analysis. In fact, it's a 106-page paper, which I mentioned just now, and out of that, more than 25 pages are included for past references. It's a very exhaustive review which has come. And they can occur at any time of the year, because earlier understanding was that they are winter phenomena, but they occur all through the year. And they are strongest and most frequent between December and May. And coming to the forecasting aspect, it's basically based on NWP products, and generally about the indication about the approaching fresh pestilence disturbance affecting Western Himalaya region from a particular date is given well in advance. We heard right in the beginning when the weather briefing, he mentioned that next WD is coming from 7th. He mentioned in his paper. And this is based on the NWP products, operational products, which we see every day on the website. And suitable alert warnings are given in advance depending on expected situation. And once having given in the bulletin that a WD is going to come, so naturally the focus shifts to observe how the weather is evolving a few days before and what is going to occur in next few days, how it is developing or not developing over any particular. And that is where we have crucial role of satellite data and products for operational monitoring. They are very important for, and the focus of this talk is on the use of satellite-derived products for operational use. And they help in better understanding of evolution of the Western disturbance and even for post-real-time analysis, where it generated, how it passed, how it strengthened, and so on. And they are proved to be very useful. I have done my own monitoring using data, and based on data past few years, I can say that products which I will be showing, they are very useful. And of course, the products you are very aware, they are basically the products from websites of IMD and Meteosat, and pictures and derived products which are winds, upper divergence, relative verticity, and so on, wind shear. And most of the time, WD can be seen in the products over East Atlantic Africa sector of the Wisconsin products. a few days in advance, which I will be showing in one of my cases. So products are available every 3 hours. That is more important, that every 3 hour update you are getting in real time and you are able to see how things are changing. And this is one product sample, which, and you can see WD appears like this in upper level divergence product. It's just an example I'm showing. And the 5 days animated sequences of these products are available on the Wisconsin website, except for the wind. But there is no GIF animation available for these products, so you can't copy and show to others. If you want to show to others, you have to copy, and then which I have done, and I will be showing for winds. And they can be prepared by the user by copying data, and they are most useful. What I found is the most useful products for WDs are animations of vorticity and the winds. And animation sequences of images are also useful both for full frame and sector animation with 15-minute image with Meteosat are also very useful. And as you know, with Meteosat and INSAT, we get a lot of RGB products. And they are also, if you go to particular sector of Meteosat, where Western disturbance originate, you can have a number of RGB products for analysis of the situation. And this is one example of air mass product and convective products. These are just examples, rainfall and so on. Winds, you can see that when a disturbance forms, the winds bring out very nicely the disturbance. And what I found is it is very useful if you monitor the full frame image every maybe every hour or every 15 minutes. They give, which I will be showing in a few minutes. And having seen a animation sequence of full frame, you can go for more frequent, more focused monitoring over a particular sector using 15 minutes update of Meteosat. And they are useful for better analysis. And of course, the Himawari products are also useful for monitoring, but to the east of 70 degree. As you know, Himawari is not able to see west of 70 degrees, but when they travel eastward, particularly of Tibetan region, Himawari products also give very useful information. And here I have shown one case of animation sequence 2020. It's a very good case. You can see that the jet is here. This is jet, and I am just moving forward in time. You can see that in fact, there are two branches of the jet. One over eastern part of Africa, and other is here. And what you find is the wind maximum from this is moving fast and catching up with the branch of the other jet stream. And you can see that I am moving forward, and you can see that a ridge is developing over this region. And after it moves further, it has started interacting with more system from the north. And at the end, it generates a trough over eastern part of the country, eastern parts of India, northeastern region. So you can see that such products are very useful. And the corresponding insert image, if you come to Indian region, this is how it appears. You can see circulation here and western disturbance in this part here. Insert image, water vapor, infrared, visible image, you can all see. And particularly with the water vapor image, you can see that once the ridge forms downstream, you can see in the upstream a trough is generated in this part. This can be seen, in fact, with the images. If you go to more focused image, you can see better. And of course, this is image for the next day. It has moved eastward. And you can see that this type of motion is very well brought out in the wind. These are the winds derived from the Wisconsin, and you can see I am moving forward in time, and they are changing as per the synoptic situation. And these two things you find here, they are the verticity maxima, and the verticity maxima also move with the jet. In fact, this entire thing is embedded in the jet and it is moving. So this is the verticity maxima. You can see verticity maxima also moving in this way. And I mentioned that if you want to do more focused monitoring, you can go to particular sector. So here I have shown a particular sector over the Indian region because the satellite is far to the west. So you see Indian region this way. So therefore, if you see continuous monitoring, you see certain features. Now, this is a very important feature. This shows that the ridge is getting formed in this area. So the effect of that is if the ridge starts getting formed, there is a circulation here which was moving eastward. So that is retarded. So this type of information you can get by better analysis of the images from the system. And for these are same images next day. Now I come to a specific, for this is again winds over the same, from the same system, but winds, upper convergence, divergence, and you can see there is another system behind. One has moved, and there is another system which is over this area, and these are the verticity chart at different levels for this. So these are the projects which, if you monitor, you can know the disturbance, how it is moving, how it is changing with time. Now, there is a very high impact weather event over North India on 8 to 12 July 2020. Himachal Pradesh, we got very heavy rains and more than, I think, 250 people died in that. And there was a strong monsoon flow and cyclonic circulation over Rajasthan and monsoon trough. So you can see that the winds, upper winds over this area. Now, I request you to focus your attention over this area. This is where the disturbance is located. And as I move forward in time, you can see that winds are changing, and in due course of time, a trough has been generated. I started on 3rd July, 0 GMT. And of course, I'm not showing every product, but I skipped certain things from the beginning, from the sequence. But still, it shows that on 9th, a trough has been generated here. Okay, you can see the generation of the trough and a ridge behind, and another ridge which has come here. So what you can see is that the effect of that trough is that the monsoon flow is very strong, so it will interact with the monsoon and generate very severe weather over these parts, which we have experienced. Himachal Pradesh and a lot of severe weather has occurred. And of course, you can see even with the, this is a product for in between dates where the upper level divergence shows the generation of thunderstorm over this area. Of course, I'm moving forward, but the important thing is I'm showing 500 HPA vorticity, which is very useful for monitoring this one. 500 I want to show. These are 850, which is of 500. This is very important to see chart of 3rd July 2023 at 3 GMT. This is where the system was. I think in the wind also you saw that the disturbance located just around 60 degree east and around 50 degree north. Kyrgyzstan and Russia border. This was the area. And if I move forward in time, you find that the vorticity first starts moving eastward, but there's another system located to the northeast here, and that has started giving its influence on this system. And you can see that as a result of influence of that system, the vorticity position has changed, and now you can see that a trough has formed over that area, which you also saw in the winds. So vorticity field also shows formation of a trough. Okay, so this type of analysis is very useful for day-to-day monitoring, operational, and even for genesis. Even 200 vorticity HPA, I have selected some of them, and you can see that at 200 HPA also a trough has started getting formed, and you can see that a very deep trough has formed. And here to the west, you have got the anticyclone to the here east also, and the trough has dipped in between over the area which we are talking about. Okay, so these are all the subsequent position of the. So basically, what has happened is there is a very big perturbation on the jet stream, which is shown here in the wind shear product. This is the wind shear product. You see the jet is here, jet around 40 degree, and our disturbance which came, it was here. So I have only selected 5 or 6, not every image. So you can see that in 4 days, there is a very big perturbation on the jet stream. And in the water vapor image animation sequence also, you can see that it is right from the beginning, 5th, then 6th, and I'm moving forward in time. The animation, it is the animation of animated sequences. Actually, moving forward in time, you can see that the disturbance is moving southward here, and as the day progresses, the time progresses, its trap is getting deeper, and you are getting weather and its interaction with the monsoon flow. So you are starting getting weather over the northwestern part, which created havoc, which I mentioned right in the beginning. And of course, you are aware that 2023, it was a very big event. So this is how it generated. You can see the genesis of this event. Now, another high impact event I'm mentioning, 27 November 23. See, generally November is the period when we don't get very severe, as you have seen these days. It's very good weather, bright sunshine, November, December. But a very big event came on 27th July, and that resulted in high impact, which I mentioned here. And after having seen that from the charts that is going to come on 27th, so I started monitoring over East Africa sector from 23rd. And this is the image from the East Africa sector, 23rd 0 GMT of Wisconsin product. So you can see the jet here, and as I move forward in time, you see that jet has started developing, and there's a circulation here. Okay, and I've skipped certain things and showing only some important. It is moving forward, but on 26th, you see there's a big change. You see a ridge has developed over this area, in this area near about Mediterranean Sea. 26th, 6 GMT, 25th, 6 GMT. So this is a very important indication that it will grow further and it will move eastward, and in turn it will generate a trough over the Indian region. That's the inference you can draw from this, and which indeed you see that now I'm showing moving forward in time and showing images of upper winds over this area. You can see that the ridge has developed. It is showing it is moved eastward and further eastward. Further is moving, and now I have shifted the sector. I have come over the Indian region. I have moved eastward on particular day 26. You can see that trough has developed over this area. Okay, and you can see development of trough and weather over the Gujarat region. And these are two images, and these are the images from INSET 3D. You can see that it has developed good development. A trough is seen, and you can see. And important thing in this was that there was interaction with the estuaries. Of course, there was system in the estuaries also. They started interacting with the trough and gave very good weather over this region. There was interaction from the estuaries. You can see it's continuing in the water vapor image, and this is a visible image. Now, as I move forward in time, the disturbance has moved eastward. And about the source of moisture, you see, this is a TPW, total pressure water vapor product, which shows on 24th, the moisture is being fed northwards. And as I move forward in time, its interaction with the low level estuaries, the moisture is moving further, and there's an interaction on 25th, 26th, and that is how a lot of weather has occurred. So you see now there's a big surge of moisture from the Arabian Sea, and this is caused weather. And of course, there's another system, a very small system, 10th, 11th November 23, a western disturbance causing rain over northern parts of the country. This was another important event which caused rain on 10th November in northern parts of the country. The western, you see the movement of the westerly trough in this 9, 10th, 11th, and it has 12th, it has moved eastward. These are images, okay? And important thing here is the 500 SPA vorticity. You see, there was a vorticity over this area. This is on 9th 0 GMT vorticity, but as I move forward, the vorticity has come down, the 500. You see, there's a big change now between previous and this one. So as this has come down, the vorticity reduction has taken place, and it has further come south, and next day it has moved eastward. This is the 12th, and further the weather has moved eastward, and we got good rains because of this. And of course, this is the same system shown in the infrared images. 850 also, good vorticity was generated at 850. I showed only 500. So at 850 also you can see suddenly vorticity generated and weather, and we got good rains with the rainfall map. In fact, in this case, whatever was shown by NWP product, it was very small rain, but what actually occurred is much more than what is shown by the model. So I think if we monitor in this way with the product, satellite product, you can see how things are changing. And now now you see Dubai period 2024 due to western disturbance. As you are aware, on 16th April, there was a very big event at Dubai, and I am showing the same type of products for this event. And if you see the weather bulletin, the PIMD, they were indicating that western disturbance is moving, is going to affect western Himalayan region from 18th. So if it is coming from the west, then 2 to 3 days before that, it should be over the region, Mediterranean region. So this is what I'm showing product on 14th, a western disturbance has moved. But there's another behind that, which is coming down. And that is the one which has produced event at Dubai. You can see that a circulation is developing at 500 SPA, and you see here it has developed now in this one. It is developed near the Mediterranean. It has come from Mediterranean and moving towards this Persian Gulf in this area, Saudi Arabia, and then this event is here actually. I will show images in a few minutes. You see now, this is next image. It has come down further. And it so happened that at that time there was a problem in the Wisconsin project. Beyond that, I could not get. So, but this has brought out that it is a very good event, and it has shown. You can see that this particular project is very important, that it is right over the UAE area. So it has given very heavy rains on 16th. So it has moved from the Mediterranean Sea and towards southern parts of Persian Gulf. And you see, important thing is that a system from the north has come down southward, and it has affected, given rise to a perturbation in the jet. You can see here. This was the system which came down and generated. You can see even the winds associated with that. There is a circulation, if you see critically, and here, this is the area of focus. So it has created disturbance in the jet, and then consequently, you got good rains over this area. And of course, this is convergence, high convergence, and you can see that a high vorticity has been generated at 858 HPA, which is very important source of information to give forecast. It has moved, and this is the one. Even on the synoptic, even on the chart, you see that same system. It is moving eastward, northeastward. On 18th, it has moved, and 500 HPA also. You can see that a big upper level cyclonic circulation has perforated. It has perturbed the jet, and you also see that same system here in the charts. You see that it has moved eastward after giving weather. And 200 SPA also, I'm not showing every, but I'm just showing one. And you see the wind shear product, there's a large perturbation on the jet, and you got very good weather because of that. And for this case, there's a study by UMETSAT. If you go to UMETSAT site, they have given a case study, and they have explained in detail what happened, the synoptic situation. They have given a lot of animation sequences. And of course, I also have a note which they have referred to in their case, and it is available on their website at this address. And this is one which I have taken from there, which they produced. In fact, they have taken the imagery from the Meteosat air mass product, and on that they have merged the isotech and the geopotential and the vorticity product, and shown that what are the causes for. This is a animation sequence of the dust cloud. Can you just put a tick on this, and then it will show animation? You just click on that. Yes. You see, this is the 4-day animation of dust product. It shows the moisture availability and how the thunderstorm developed and moved across, and they produce the gust front. These are also seen in these images. So this gives complete sequence, and you see pink, lot of dust has been raised because it's a desert source. It's a desert area. After the event, dust is seen on this. And of course, this is the visible imagery. You see the dust. These are taken from UMETSAT site, and you can go there and see all of them one by one. And with their you see a lot of thunderstorm development with overshooting tops, which shows the severity of the system. Can click on this. Can you click on this image? This will also show an animation. Okay, this is an animation of the visible images, which shows a very severe development over this area on 16. Okay. For now, on 17, system has moved further eastward, and this is an image of the same product from the meteor set. It is moving eastward on the 17th, it has moved, 16th, it has given very good weather over the Bay Area. And you see, important thing is here, the moisture. TPWD product, it shows very important feature in this product. On 15th, you see the moisture here in this region. It's very moist. There is no depth of moisture, which is a very important ingredient for thunderstorm development. And on next day, what has happened is a very pointed source of moisture, over a very small area, the moisture is concentrated. It's in fact over the Bay Area, the circulation is, and behind that you have got dry air. After giving weather, it has moved eastward, and dry air has come from behind. So this TPWD product also shows very important feature of this sequence. Of course, this image I have shown because after 3 weeks after that event, this was on, I think, 2nd May, again some heavy rain started occurring over Dubai, and they were worried whether it will also give event of that type, but that was a different system. It didn't produce that kind of. And here I'm showing a different case now. I have moved from Dubai, a very small case where very deep amplitude trough is, it has crossed, it has moved, there's a perturbation on the jet, and it has affected track of the cyclone. This was Oki cyclone, which formed here in 2017, 30th November, moved here, and it is here on 5th December. And you can see that a very deep trough, the type of trough which I showed for the event earlier, a few minutes ago. This is another case where a very deep trough can affect, and these are seen in the products. That is the important thing. You can see their animation in the products, and you can see the Wisconsin products, and you can see picture. In fact, in December, you don't see this type of picture. It's very rare. As Sai Saab mentioned, it's a bright sunny day today. But in 2017, it is, I think, same day, 5th December, you had very good weather, and you got even chart shows 6 days on 5th that there is going to be rain on the 11th. Okay, so you can see that it here, this is so in December sometime you can get this type of weather in North India. It's not bright sunny day every year. It's year to year variation. And on 11th December, we did get good rain. And of course, I am not going to take much time now. I want to go towards, and there are even another case of 7 December 2020, you can get good weather over North India. You can see that. And why I was showing this is because, see, sometime in the water vapor images, you see this kind of, but these kind of disturbances. You can very often you see dark areas in water vapor images moving here and moving from the boundary. These are actually 500 SPA verticity points. So 500 SPA verticity maximum over this area. So that's why I've chosen this case to show the image. And I skipped some of them, not everything. I don't want to show. Okay. And of course, I want to show that if you go to a particular sector of meteor set, you can do very detailed analysis. In fact, these images are every 15 minutes and RGB product, number of RGB products. I'm only showing water vapor and infrared. Even winds are superimposed on this in some of the images. You can analyze the image where the circulation is. In fact, this circulation will be very well brought out in the winds. And of course, there's a 2020 case. I think Dr. Mitra had given me this image, the lightning data superimposed on the image. And you can see the 20th February, there is a circulation here. Okay, in the water vapor image, it's very well seen, circulation, and it's going to give weather over North India. And there's another which is coming ahead. So December, you don't get much weather. February, as season progresses, January, February, you start getting. And you can see that even in such cases, sometimes there's a moisture transport towards this disturbance. From Arabian Sea, the moisture is produced. So in summary, I would say that the satellite-derived products are very useful for monitoring WDs and tracking their genesis regions. They respond very well to changing synoptic situations, so they are very high quality because as the situation changes, the derived product should reflect that. This is also, it should show the change. And monitoring with more frequent updates over smaller sectors, they provide a lot of useful information. And my acknowledgements are to IMD team, to whom whenever I contact, they give any data, any information, particularly Dr. Mitra and his group. And Wisconsin University, they are always very supportive and tropical cyclone group. In fact, in about 3 years back, I made a request that you increase the coverage area of some of your products. And within a week, they did it and made it operational. So now the disturbance which I could monitor, which I showed in the beginning, it was because they increased the northward coverage area. If they had not done that, maybe I would not have been able to monitor. And Professor Hunt and Professor Dimri, in fact, for the paper which I mentioned, on the paper which I saw, I had a small observation and I sent a mail to Professor Hunt. And I think within 10 minutes, he responded and clarifying that point and saying that here is the accepted version of the paper, which is going to come after a few days. Within 10 minutes, I got his response. So they're very supportive. And so thanks for your attention.
Thank you, sir, for the wonderful talk in Western disturbance. I think you have very insightful and you explain in detail with not only INSAT as well as Meteosat and other regions, the Western disturbances. The only thing which I would like to add here that the strongest WD is now couple of years we are also facing during the monsoon month. If you recall in year 2022 in July, the vigorous WD over the Northwest India has arrived. You have 23, yeah, 20. Yes, yeah. So, so it is very, very important. And for Northwest India, WD is the main source of driving force over the agriculture sector also. So, quick one question I would like to ask because I have to make a quick announcement also. So, if anybody in the hall would like to ask any question, okay. If not, then yeah, only one, yeah.
Good morning, sir. Sir, my question is, as you have mentioned, Arabian Sea is the main source for the Western disturbances, but all of the region is starting from the Mediterranean Sea. So how as a moisture source? Okay. Okay.
And the which I mentioned, Dr. Hunt, she has clarified and then isotope analysis. They show the dirt and things, and now based on this, they say that radiance is also very important.
It is also contributing, right?
But he has mentioned 33 points which require further research. These exact points he has mentioned.
Okay. Thank you, sir.
Thank you, sir. So we may have a discussion during the coffee break also. So now I have to make one announcement. We'll be having our inaugural session sharply at 1 o'clock. Honorable Minister is coming at sharply 1 o'clock. So we'll be having early lunch. Lunch will be available in the ground floor, common area. And we have to rejoin here at 12:45. I repeat, 12:45. We have to come back again here in this room. So we will be proceeding for the lunch. Thank you. Sorry, just I forgotten. We are not cancelling Satya Kalluri sub pre-recorded video. This we will manage in today in some session. Yeah. Thank you. Ground floor, common area.
for satellite development. Initially, satellite was aimed for detecting and predicting drop
Ladies and gentlemen, may I have your attention, please? Please bear with us for this inordinate delay. Honorable Minister of Arts Sciences is expected to arrive in another 10 to 15 minutes.
Department is inaugurating the INSAT 3DS products. The INSAT 3DS satellite is a follow-on mission of the third-generation meteorological satellites from geostationary orbit. The GSLV F-14 INSAT 3DS mission is fully funded by the Ministry of Earth Sciences. The purpose of using INSAT 3DS is to monitor Earth's surface, carry out oceanic observations, and assess its environment in various spectral channels of meteorological importance. The imager on board INSAT 3DS captures multispectral images in visible, infrared, and water vapor bands. It provides information on land surface. The India Meteorological Department is inaugurating the INSAT 3DS products. The INSAT 3DS satellite is a follow-on mission of the third-generation meteorological satellites from geostationary orbit. The GSLV F-14 INSAT 3DS mission is fully funded by the Ministry of Earth Sciences. The purpose of using INSAT 3DS. The India Meteorological Department is
Excuse me, everyone. A gentle reminder for those who have their oral presentation in Hall 6. If you have not submitted your presentation, kindly give it to tech team on the right. Thank you so much.
Ladies and gentlemen, may I have your attention, please? Let us greet Honorable Minister, Ministry of Earth Sciences, Dr. Jitendra Singh. I request Honorable Minister, Ministry of Earth Sciences, Dr. Jitendra Singh, Secretary, Ministry of Earth Sciences, Dr. M. Ravichandran, Director, Space Application Center, ISRO, Shri Nilesh M. Desai, Director General of Meteorology, Dr. M. Mohapatra, Chair, AOM SUC, Dr. Ellen Hang, Director General of Regional Office for Asia and the Southwest Pacific at the World Meteorological Organization, Dr. Ben Churchill, Head Satellite Meteorology Division, IMD, Shri K.C. Sai Krishnan, to kindly proceed on dais. Honorable Minister, Ministry of Earth Sciences, Dr. Jitendra Singh, Secretary, Ministry of Earth Sciences, Dr. M. Ravichandran, Director, Space Application Center, ISRO, Shri Nilesh M. Desai, Director General of Meteorology, Dr. M. Mohapatra, Chair, AOM SUC, Dr. Ellen Hang, WMO Representative, Mr. Ben Churchill, Head Satellite Meteorology Division, IMD, Shri K.C. Sai Krishnan, invited guests from WMO, NOAA, GMA, KMA, CMA, Bureau of Meteorology Australia, BMKG Indonesia, representatives from Asia-Oceania region, officials from Ministry of Defense and other sister organizations of MOES, delegates, scientists and officers, colleagues, friends from media, ladies and gentlemen. Namaskar and a very good afternoon. On behalf of India Meteorological Department, I, Sarita Gupta, extend a very warm welcome to the inaugural session of 14th Asia-Oceania Meteorological Satellites User Conference, AOM SUC 2024 at New Delhi. AOM SUC is a unique mechanism for facilitating dialogue and improved collaboration among the space agencies and user communities in the Asia-Oceania region, and for enhancing the use of satellites for weather, climate, and disaster mitigation services. Over the past decade, the AOM SUC has become the premier annual event for meteorological and earth sciences community across Asia-Oceania, where satellite operators, users, scientists, and students across the globe come to share their findings and plans for the use of meteorological satellite data. Starting from 2010 till now, conference has been held at China, Japan, Korea, Australia, Russia, Indonesia, and this is the 14th conference being held in India for the first time. We commence the inaugural function by welcoming the dignitaries seated on dais. It is an honor to welcome the chief guest, Dr. Jitendra Singh, Honorable Minister of State, Ministry of Earth Sciences, the man of distinct vision and a fountainhead of illuminating ideas. I request DG IMD sir to kindly welcome Honorable Union Minister, Dr. Jitendra Singh. Hearty welcome, sir. I am honored to welcome the guest of honor, distinguished scientist Shri Nilesh M. Desai, Director, Space Application Center, ISRO. He is an expert in design and development of space-borne instruments and associated applications. I request DGIMD to kindly welcome Shri Nilesh Desai. Warm welcome to you, sir. We feel honored to have with us Secretary, Ministry of Earth Sciences, Dr. M. Ravichandran. With his vast experience and knowledge, he is an inspiration to all of us. I request DJIMT to kindly welcome Dr. M. Ravichandran. Warm welcome to you, sir. It's my pleasure to welcome Chair AOM-SUC, Dr. Alan Huang. He is a distinguished scientist emeritus, University of Wisconsin-Madison, USA. I request DGIMT to kindly welcome Dr. Alan Huang. Hearty welcome to you, sir. With equal pleasure, I welcome Mr. Ben Churchill. He is an experienced strategic leader in climate, weather, water, and environmental policy and services. I request DGIMT to kindly welcome Mr. Ben Churchill. You're welcome, sir. I respectfully welcome all present here for gracing this occasion. Before we proceed further, let's begin the program with lighting of the ceremonial lamp and Saraswati Vandana for invoking the blessings of Goddess Saraswati. I request Honorable Minister Dr. Jitendra Singh and other dignitaries on dais to kindly light the lamp and my colleagues to render the Saraswati Vandana. शारदे मां शारदे मां सत्यानता से हमें तारदे मां शारदे मां शारदे मां सत्यानता से हमें तारदे मां शारदे मां शारदे मां सत्यानता से हमें तारदे मां स्वर्ग देवी संगीत मुझसे हर शब्द मेरा हर गीत मुझसे स्वर्ग देवी संगीत मुझसे हर शब्द मेरा हर गीत मुझसे हमने अकेले शरण हम प्यार देवा हमने अकेले अधूरे तेरी शरण हम प्यार देवा हे शार देवा हे शार देवा अज्ञानता से हमें तार देवा हे शार देवा हे शार देवा अज्ञानता से हमें तार देवा ने समझे ने जानी वेदों की भाषा पुराणों Thank you. India Meteorological Department is celebrating 150 years of services to the nation. Let's hear the IMD theme song that summarizes the services of IMD.
मौसम विभाग वंदे मौसम विभाग वंदे हम हर मौसम पढ़ने वाले मानव जीवन के रखवाले वसुधा परिवार हमारा है मौसम विज्ञान सहारा है
पृथ्वी की गतियों का निदान दिखाता शाश्वत संविधान
जलवायु में पर्यावरण के परिवर्तन का ज्ञान
से हो सतर्क सब आएंगे अभियान जल थल नंबर हर गांव नगर पर्वत घाटी जंगल सागर जीते हम संग फिजाओं के लाते संदेश हवाओं के
सहयोगी किसानों के जन जीवन की मुस्कानों के कर्तव्यनिष्ठ मौसम प्रहरी जल सेवा में आस्था गहरी
करते अध्ययन किसानों के नव चक्रवात अनुमानों के
जन धन जीवन रहे सुरक्षित मंथन अनुसंधान मानवता के लिए समर्पित मौसम का विज्ञान मानसून संज्ञान ग्रीक संस्कृति का नव विहान ऋषि चाणक्य का अर्थ ज्ञान कवि कालिदास के मेघ आदित्य प्रभा के अग्रदूत
उपग्रह का दिग्दर्शन ऋतु चक्र प्रवर्तन विश्लेषण
भारत के स्वर्णिम कल के लिए शुचि मन में दृढ़ संकल्प लिए
साक्षी समृद्ध विरासत के हम गौरव प्यारे भारत के
पूर्व पश्चिम उत्तर दक्षिण शुभ कर्म योग संधान सीमाओं के पार हमारी करुणा की पहचान सहयोगी गुणगान
Director General of Meteorology, Dr. Mrityunjay Mahapatra, has been instrumental in steering IMD to new heights by improving disaster mitigation and risk reduction services during severe weather events. I feel privileged to invite Director General of Meteorology, Dr. M. Mahapatra, to kindly deliver the welcome address.
Good afternoon, namaskar to all of you. Honorable and respected Dr. Jitendra Singh, Honorable Minister of State Independent Charge, Minister of Arts Sciences, Minister of State Independent Charge, Minister of Science and Technology, Minister of State in the Prime Minister's Office, Minister of State of Ministry of Personnel, Public Grievances, Pension, and Minister of Space. Guest of honor of this function, the Director of Space Application Center. We have with us, as all of us know, the thought about the satellite applications comes in India only with the contribution of Indian space research organizations. And the application products developed by satellite is steered by the Space Application Center. So here we are happy. We have Dr. Nilesh Desai Sahab as guest of honor in this program. Dear Dr. Allen, the chairperson of the Asia-Oceania Meteorological Satellites Users Conference, Dr. Ben, representative of World Meteorological Organizations, our beloved Secretary, Minister of Earth Sciences, Dr. M. Ravichandran, distinguished participants from various countries of Asia-Oceania region, distinguished delegates from different countries of WMO and otherwise, distinguished participants within the Ministry of Earth Sciences and outside, delegates from ISRO, Indian Air Force, Indian Navy, and various other users within the country and outside. At the outset, I extend a warm welcome to our Honorable Minister of Earth Sciences, Dr. Jitendra Singh Sahab. We also express our heartfelt gratitude to our Honorable Minister, as because of his busy schedule, he still could find time and be present here to provide us the guidance to move forward in this field of satellite applications for weather and climate services, and finally, the service to the society. Dr. Jitendra Singh Sahab is a man of responsibility, man of sincerity, man of dedication, and we all know his role played in the government of India. His thought, his plan and policy has gone a long way, not only in India Meteorology Department, but in the entire scientific community of the country, to bring out a paradigm shift in the approach of the science ministries, in the approach of the scientists and engineers to serve the society. Under his able leadership, we have seen the integration of the scientific community. Just like we have an integrated approach in the Ministry of Earth Sciences, we have also an integration with respect to all the science ministries, about 6 to 7 ministries in the government of India and also the states. He has also played a key role in international collaborations with respect to the development of science and technology and its application to the society. So I, on behalf of India Meteorological Department, Minister of Earth Sciences, I extend a warm welcome, sir, and thank you very much for your gracious presence. Dr. Nilesh Desai Sahab, he is the brain behind the latest development in the satellite applications. As we move ahead from the beginning of 1960, when the world came across the development of aerosol satellite for meteorology, and gradually we came up with various satellites with a humble beginning in 1957, release of Aryabhatta, then Rohini and Bhaskar, and then the geostationary satellites in 1982. The Satellite Application Center of India Space Organization has played a dominant role in collaboration with the India Meteorological Department. It is needless to mention that the entire satellite meteorology development in the country took place with the dominant role played by IMD along with Indian Space Organizations. The first committee formed by the country to develop the Indian Space Organization has the representation with the presence of Director General of Meteorology as a member of the expert committee. So from there on, the collaboration went on, and with your able leadership, we have marched ahead, and we have a joint development of all types of algorithms, products, and applications for not only for betterment of the monitoring, but also its application in forecasting, modeling, and finally the end-to-end services to the human being. So thank you very much, Desai Sahab, for your presence here. I also extend a warm welcome to our chairperson, Dr. Allen. He has been the brain behind for coordinating the various agencies for successful conduct of this meeting today. This is the meeting we conducted for the first time in India. And the event started in 2010 when we thought that the satellite users across the globe should confer with each other should find out the common problems, the gap areas in the development side and also in the application side of the satellite with respect to meteorological sciences and services. So every year we gather to identify the current status of the satellite applications for weather and climate services, especially with respect to extreme weather events, what are the gap areas, and what are the actions taken based on the last recommendations and plan for the future. So thank you very much for your presence here and your able leadership internationally to take up these issues. I also thank Mr. Ben for your presence here as the representative of WMO, and you are representing the Asia-Oceania region. And there are planned activities in this series also. We have a meeting of the countries of Regional Association 2 and Regional Association 5 on 7th in Delhi. And your contribution has helped us to successfully organize this interactive meeting, coordination meeting, to plan further the policies for better application of the services. I want to mention here the Asia-Oceania region is dominated by the island nations, is dominated by the poor countries, least developed countries. Therefore, here the application of satellite plays a dominant role because the direct observations through radar and automated stations, etc., becomes difficult for the poor countries and the oceanic region here. So due to these data spheres and due to socioeconomic conditions, the conference, which is being organized from today, will continue for 3 days, will be a very handy to hence further utilize these products for these poor countries and least developed countries and island nations. Dr. Ravichandran has been the brain behind the activities in India Meteorological Department, Minister of Earth Sciences. With his able leadership and guidance, we have come here to this stage to have this gathering, to have this concept of organizing this international conference. He has been a scientist in general. In particular, he has worked in the field of meteorology, oceanic sciences, and or allied sciences. He has been associated with the observational components, the modeling components, and also the service components, as he has worked in various organizations in his past 30 to 32 years of service. So thank you very much, sir, for your guidance and leadership with which IMD is progressing to scale the new heights. I just want to mention 1 or 2 points that the satellite application has gone way ahead, starting with the immediate detection of the cyclones in the Bay of Bengal Arabian Sea. Then we address towards the understanding of the monsoons. Various components of monsoons we understood with the help of these satellites. Then we came up with understanding the synaptic features, satellites, thunderstorms, low pressure systems, monsoonal characteristics. And finally, we could be able, with the development of the INSAT 1 series, then 2 series, and 3 series, now we're going for the 4th series, we could be able to integrate the data in our numerical weather prediction models. Our data are not only utilized within IMD, as a partner in a coordinated group of meteorological satellites, we also exchange data with all the countries. And this association helps us to exchange the ideas, exchange the data, and exchange the models based on satellites to further improve our services. So finally, I welcome all our distinguished participants. Your presence only makes it successful. Your coordination, collaboration, interaction during the past years has helped to reach this stage. I am sure in this conference also, you will continue to contribute and will scale the new heights. I just want to mention you, sir, this is 6 days program. Last 2 days we met here with a 2-day international training program organized by IMD on the satellite applications for weather and climate monitoring, modeling, and forecasting services. And these 3 days, 4th, 5th, and 6th, we will have this international conference. About 200 research papers has been received, which will be presented and discussed in this forum. It will be followed by 1-day international coordination meeting between the countries of Regional Association 2 and Regional Association 5, which covers Asia and the Oceania. Sir, thank you very much. I once again welcome all the distinguished delegates, Honorable Minister, and all the distinguished guests in the dais to this important conference of AOM SUC. So thank you very much.
Thank you very much, sir. Next, we present a video showcasing the informative impact of satellite services, highlighting how they are shaping the future of weather services. The video also provides information about AOM-SUC.
4, 3, 2, 1.
L40 stage are ignited.
ये अनंत अंतरिक्ष में भारत के वैज्ञानिक सामर्थ्य का शंखनाद है.
When India got its independence, there was no satellite observations worldwide, hence entire oceanic and hilly areas were not monitored. The era of satellite began in 1960s with launch of TIROS satellite by United States. India was one of the beneficiaries, which utilized the observations taken by the satellite. In 1963, high-resolution picture transmission system at Kolaba, Mumbai was established. Early beginnings. The Indian Space Research Organization ISRO was founded in 1969, setting the stage for India's space exploration and satellite development. Initially, satellite was aimed for detecting and predicting tropical cyclones. Gradually, satellite applications were used for detecting all types of weather applications, including severe weather events across the globe. However, in 1975, the Indian government established a high-level committee for the country's national satellite that included ISRO authorities and DGIMD. The INSAT series began with the launch of INSAT-1 in 1982 with subsequent advanced satellites such as INSAT-2 and INSAT-3. Although its primary purposes include telecom, broadcasting, search and rescue, operations also had meteorological instruments, marking the beginning of the era of satellite meteorology in India. Presently, we have third-generation satellites. INSAT 3D, INSAT 3DR and INSAT 3DS. Now we have multispectral imager with 6 channels and sounder with 19 channels data products giving complete 3-dimension vertical profile of temperature and moistures. With the launch of OceanSat 3 in 2022, sea surface wind monitoring also got enhanced. During 2014, the development and implementation of RGB, cyclone enhancement images of INSAT 3D introduced the satellite-based cloud classification, and it proved to be useful for the forecasters in identifying the location and intensity of severe weather. A dedicated calibration validation site is being used for INSAT series of satellites. A rapid scan in every 5 minutes being used for monitoring severe weather phenomenon like cyclone, thunderstorm, etc. INSAT 3DS recently launched in Feb 2024 has improved blackbody variation tolerance and sounder payload. It is needless to mention that the 95% of data being assimilated in the models are based on satellites. This year, the 14th conference of EOMSAC is being held in New Delhi, India. Over the past decade, the EOMSAC has become the premier annual event for the meteorological and earth sciences community across Asia-Oceania, where satellite operators, users, scientists, and academia gather to share their findings and plans for the application of meteorological satellite data.
More than 100 abstracts have been shortlisted for presentation in AOM-SUC 2024. I request Honorable Union Minister Dr. Jitendra Singh to kindly release the book of abstracts of the papers being presented in this conference. Thank you, sir. INSAT 3DS is the last satellite in INSAT 3 series. It was launched in February 2024. The data products are now being brought into weather forecasting services of IMD. I request Honorable Minister to kindly dedicate the products to the nation.
The India Meteorological Department is inaugurating the INSAT 3DS products. The INSAT 3DS satellite is a follow-on mission of the third generation meteorological satellites from geostationary orbit. The GSLV F-14 INSAT 3DS mission is fully funded by the Ministry of Earth Sciences. The purpose of using INSAT 3DS is to monitor Earth's surface, carry out oceanic observations, and assess its environment in various spectral channels of meteorological importance. The imager onboard INSAT 3DS captures multispectral images in visible, infrared, and water vapor bands. It provides information on land surface temperature, sea surface temperature, cloud cover, aerosol optical depth, and water vapor content. The sounder on board provides vertical profiles of atmospheric parameters such as temperature, humidity, and ozone. INSAT 3DS also features rapid scan capabilities to monitor severe weather conditions like cyclones and thunderstorms. The imager instruments are equipped with a flexible scanning feature known as program mode, which allows for the programming of the number of scan lines over a given region and the number of repetitions for scanning. This capability is crucial for severe weather applications such as nowcasting and tropical cyclone analysis.
Thank you, sir. Dr. Jitendra Singh, Honorable Minister of State, Ministry of Earth Sciences, Minister of State, Ministry of Science and Technology, Minister of State in the Prime Minister Office, Minister of State, Ministry of Personal, Public Grievances and Pensions, is a distinguished leader and a prominent figure. He is widely recognized for his unwavering commitment to the advancement of technology, science, environment, and human health, among others. I am honored to invite the Honorable Minister, Dr. Jitendra Singh, to share his valuable thoughts with us.
Thank you. Good afternoon, everybody, and welcome. Seated on the dais with me, the guest of honor and also the director of Space Application Center, Ahmedabad, one of very eminent space scientists, Dr. Nilesh Desai, chairman of the Asia-Oceania Meteorological Satellite Users, Dr. Ellen Wang, director, Southeast Asia, WMO, Dr. Ben Churchill, my colleague in the Ministry of Earth Sciences, and a very eminent scientist, Dr. Ravi Chandran, Dr. M. Mahapatro, Dr. K.C. Sri Krishna. You heard just now, Dr. Mahapatro very elaborately describing each one of us sitting on the platform with his very kind and generous comments. So I think it becomes obligatory for me to pay back the compliment, if not wholly, to a small extent. So I must appreciate Dr. Mahapatra for organizing this conference, for being the person who has been doing all this networking to get all these delegates from so many countries over here. I know how difficult it is to organize an event like that and how many months it takes of correspondence and adjusting dates with each of the delegates and the faculty members, and also arranging for the reservations and getting them sometimes altered also if required. And that also speaks of his proactive disposition. He has been very passionately involved in the business of weather, though the Delhi weather has not been always very kindly responding to him. And he's been traveling to and forth. And in fact, once or twice we had to request him to care more about the local weather than the international weather, because he had so many international assignments, which of course is a compliment to his standing in the domain that he has expertised. So at the outset, I have to also thank you for making me a part of this event by giving me an opportunity to inaugurate the Asia-Oceania Meteorological Satellite Users Conference 14. And I was discussing with Dr. Mahapatra, this event which has now become a regular feature every year, has almost become a beacon of collaboration as far as the satellite application is concerned. And every year, we tend to move on further from where we were last year. So that progressive journey, which is led by these series of conferences, I think is also resulting in outcomes which would be useful to all the nations involved. And that also I was just now asking Dr. Ravi Chandran about the composition of the audience here, and I was really impressed. I think it's not an area which is very popular in the common parlance or even among laymen. They would take some time to understand what the meteorology means, even some time to think what earth sciences means. But in spite of that, if we have such a presence over here, that is also a reflection of your collective commitment to this cause, to the cause of weather forecasting research and addressing the challenges posed in the contemporary world by issues like climate, etc. And I think in another way also, this is happening at an incidental time when very recently, in fact, under Prime Minister Narendra Modi, the cabinet of the government of India rolled out what is now known as Mission Mausam. And this is, I think, for the first time happening after independence, that the government of India has come out with a scientific initiative dedicated exclusively to climate and everything else related to climate, which was perhaps never a priority with the political dispensations earlier. But this also is an indication of the futuristic approach of the Prime Minister and the government headed by him. India is now looking forward to play a global role in the global issues, global challenges. And if we have to do so, we have to live up to the global parameters and the global benchmarks. And Mission Mausam is a step towards that. And since we always look for evidence for what we say, I was pleasantly amused yesterday when the minister from Israel wanted to learn about this mission from us. He was here for some other purpose. And the lady accompanying had asked me, I want to get in touch with somebody who will tell me Masoom or Masoom programs. So she couldn't pronounce it actually. So I also couldn't make it. So it took me 2-3 minutes to understand. But that means we have caught the imagination of the scientific world outside India as well, which was not happening earlier. Earlier, we would get enamored by what they were doing and then try to emulate that. Today, others are trying to understand because, of course, Israel is a country of just about 10 million people, but innovation-wise, technology-wise, it's way ahead of many others. So they too found something useful or something new happening. So I'm glad that we are now holding this conference at a time when India is on its way forward. And of course, as the video just now was showing, till about 1960, we didn't have much of weather forecast facility. The weather forecast broadcasted on the radio was usually an object of fun and humor, because they said if the weather forecast had said it would rain, be sure it would not. Because the lady announcing that has seen the weather in the room, not outside. But then, of course, it's not to grudge neither the broadcaster nor the scientific fraternity, because we didn't have much of it. But as the video was depicting, if America got into this business in the first half of the 1960s, we got into it in the latter half. So we were very quick to actually come forward. In 1969, the ISRO was established, and soon after, one after the other, this series began. And then, of course, the INSAT series, and today we have this INSAT 3-dimension. And therefore, this conference, I'm sure, is vital in fostering collaboration among the satellite operators in this region, the region of Asia-Oceania, and would also provide a platform for satellite technology applications, advancements, exchange of thoughts, exchange of knowledge, and also exchange of the best practices. And I was going through the scientific program. I was quite gratified. The diverse and the wide range of themes included, I'm sure this is going to have an impact. And also taking care of including the newer options like artificial intelligence, machine learning, etc., and geoinformatics in the business of forecast. India today is in a position where we are also offering this service to the neighboring countries. So we have Dr. Desai from the Department of Space. He would wear me out, I think, way back, I think somewhere in 2015 or 2016, we came out with, which is something called the, that's a satellite, the G20, no, we came out with a satellite which caters to all the neighboring countries. So it was South Asia satellite. Yeah, GSAT-9 is the South Asian satellite, which incidentally Pakistan for their own reason did not become a part of it, but we are catering to Nepal, to Mongolia, to Bangladesh, to Sri Lanka, all the neighboring countries. As far as our weather forecasts are concerned, also disaster forecasts are concerned, also the measurement of the magnitude of disaster after it has happened. So we are, and that is very much in tune with the mantra that Prime Minister Modi keeps reiterating, neighbors first. So we are now not only looking after ourselves, but also going beyond that. And there have been rapid strides in the space sector and also in the meteorology sector. And now we are very much, of course, these two areas were integrated, but now we are into an extended integration. And we have AI also, we have machine learning, soon we'll have quantum technology also. So it will be a wider extended synergy. And that is what is now going to be the norm in the practice of most of these scientific initiatives. And to that extent, I'm sure when we hold this conference next time, we'll have a wider integration and even other stakeholders included in this. The GSAT-16, GSAT-30, and now the INSAT 3D always been some of the landmarks in the journey of ISRO. And therefore, integrating satellite data with the IMD operations has already made a tremendous change in our specificity, in our accuracy. And when we have the AI and the other components, I'm sure this is going to make a considerable value addition to that, and also going to contribute to a deeper understanding of climate change and the other issues. We are already committed in the COP meeting also to target zero by 2070, net zero. And therefore, we have a lot of areas extended also beyond weather. And this government, I can assure you, is very forthcoming in forging ahead these kind of integrated approaches and the integrated endeavors that we see in this room today. Incidentally, I think what is also required, and next time we'll do that, you can hold a small workshop or a briefing for the opinion makers, not necessarily the newspapermen, because they don't have interest in weather. They'll criticize you only if the weather goes wrong. Otherwise, they'll never report your news because their interest is different. But for the opinion makers, because of the fact that your figures, I was going through the other day, indicated, because that was a question in the parliament in the current session itself, your figures indicate with evidence that there is a statistical evidence, there's a 40 to 50% improvement in the weather forecast. Whereas in the popular parlay, it's the other way around. They say the forecast has gone from bad to worse, which is a part of the casual gup-shup club origin. They don't verify facts, but they take fancy in saying so. So I think we also next time would have a session in the conference itself. We have started doing in the medical conferences also, and we also sometimes have a session dedicated to public. In fact, way back, even about 1 or 2 decades back, whenever we had a diabetes conference, we would get one of the eminent diabetes patients to talk about it. And sometimes they would talk better than the diabetologist. And once we had this famous cricketer from Pakistan, Wasim Raja. He used to use insulin even during the game. Sorry? Wasim Akram, Wasim Raja, Wasim Akram. And then, of course, he also became brand ambassador for one of the companies called Novo Nordisk. He used to spend a long time in India. Then once I roped in Mr. Arun Jaitley also, but incidentally, he became a minister. Soon before the conference, he said, now it would not be proper for me. He did not invite the kind of right kind of. So I think that's what we need to tell people, that the weather is not as bad as they think. And that would be the ultimate litmus test for all the efforts, endeavor, hard work being put in by Dr. Mahapatra and his team. Congratulations once again. I'm sure, besides the academic fees, your hospitality is also being taken care of. Otherwise, Dr. Mahapatra will be answerable, not anybody else in the room. Thank you.
Thank you, sir, for enlightening us with your wisdom. I request DG Andy to present a memento to Honorable Union Minister as a token of love, respect, and gratitude from India Meteorological Department. Thank you, sir. Because of his other pressing assignments, Honorable Union Minister Dr. Jitendra Singh has to leave. We are thankful, sir, for sparing time from your busy schedule to grace this occasion. Kindly be seated. Let's proceed further with the program. Dr. Elaine Huang is a distinguished scientist emeritus, permanent principal investigator, University of Wisconsin-Madison, USA. Fellow of International Society for Optical Engineering students. I take this opportunity to invite Dr. Elaine Huang to address the audience.
Thank you. Again, welcome to our sessions that we come here from far away, from many countries. We want to come together with a common goal. What is that common goal? Learn from each other, support each other, requesting and asking for helps that you needed, that's unique to you. So with that spirit, we want to work together to harness, and that's the beautiful word I always want to use, harness something. Harness from what? That matters to us, to protect our society, to see the futures, that the weather impacts on many areas. So with this common goal, I think I want to encourage yourself and inspire all of us that we come together, provide the common tools, common knowledge, common data to solve your own unique problems. So we are here to exchange ideas. We are here to share informations. We are here to voice our needs to those countries who are contributing so much, who are investing so much, who including your United States government. United States government have been funding my team, myself, over many years to provide the best tool to provide the best educations, trainings to all of us. For the reasons that because we have one world, we have one earth, okay? And so they invest so much, and European colleague is the same. They launched this billion-dollar system. They have this geostationary low Earth orbits that provide the best microwave data, best infrared data, and they want us to use it. So I thanks our European colleague to do that. And our own area, Asia-Oceania. Again, this conference is organized and hosted under the leadership of WMO. Okay, WMO always promoting harmoniously, organization work together, solve same common ground, same common problems. And so we have this Chinese Meteorological Agency, Japanese Meteorological Agency, Korean Meteorological Agency, Russian Federations, Indonesia BMKGs, Australia Bureau of Meteorology, and of course, our host in India Meteorological Department, IMD. All together, again, is to share some common knowledge. And today we are here. So we have obligations to learn from each other, take these precious moments, turn into the knowledge. When we go home, we are loaded with information. We are loaded with tools that you can share with your friends, your colleagues, and together you help your country, we help the world, one piece at a time. So thank you again to giving us this opportunity so that we can get together, solve the problem with a common goal. And again, we thank WMO for your leaderships, for your support. We thank you, host IMD, for their gracious, beautiful meals, beautiful facility. We thank them all. And thank you. Let's get the best out of this together and from this 3 days meeting and another coordination meetings that take this knowledge one step further. Thank you so much.
Thank you, sir, for sharing your valuable knowledge with us. Mr. Ben Churchill is leading the management and operation of WMO Regional Office for Asia and the Southwest Pacific to support 59 WMO members through collaboration and innovation. I invite Mr. Ben to kindly address the audience.
Allow me to adjust the microphone. So many of the distinguished participants are out of the room, so my introduction is going to be a lot shorter. So I'll just start with the brief version. Oh, Dr. Mahapatra is back. So distinguished government officials, Dr. Mrityunjay Mahapatra, Director General of the India Meteorological Department, also the permanent representative of India with the World Meteorological Organization, and also the third Vice President of WMO, Dr. Alan Huang, the chair of the Asia-Oceania Meteorological Satellite Users Conference, International Conference Steering Committee, participants, ladies and gentlemen. It is my great honor on behalf of the WMO Secretary General, Professor Celeste Saulo, to extend a warm welcome to all of you to the 14th Asia-Oceania Meteorological Satellite Users Conference here in New Delhi. I would like to begin by expressing my gratitude to the India Meteorological Department, IMD, for hosting this conference. I extend my sincere appreciation to Dr. Mahapatra and all IMD colleagues for their outstanding efforts and also for their warm hospitality. I have learned just recently that India Meteorological Department is celebrating its 150th anniversary, and I really appreciate the video that we saw earlier. Over the years, IMD has achieved remarkable milestones in the fields of atmospheric observation, weather prediction, and service delivery to its user community. Notably, the launch of the INSAT Meteorological Satellite Series has provided essential support for disaster prevention and protection, benefiting not only the people of India, but also those in other countries. On this occasion, I would like to extend my congratulations to IMD on its 150th anniversary and commend its outstanding contributions to meteorology and public service. You may recall that the memorandum on the Asia-Oceania Meteorological Satellite Users Conference, titled "To Maximise the Use of Meteorological Satellites for Sustainable Socio-Economic Development," was signed by the permanent representatives of Australia, China, India, Indonesia, Japan, the Republic of Korea, the Russian Federation, as well as the World Meteorological Organization and the Group on Earth Observations during the 68th session of the WMO Executive Council in Geneva in 2016. However, the history of AMSUC dates back to 2010, when the Australian Bureau of Meteorology, the China Meteorological Administration, the Japan Meteorological Agency, the Korea Meteorological Administration, WMO and GEO came together as sponsors of the inaugural AMSUC conference held in Beijing. At the 2014 conference, Roshydromet, the Russian Federation National Meteorological Service, joined as a sponsor, and at the 17th WMO Congress in 2015, India and Indonesia also joined AMSUC. Since then, 13 conferences have been held annually, hosted by Australia, China, Indonesia, Japan, Republic of Korea, and Russia. And this year, as we've heard, marks the first time that the conference is being held in India. Over the past decade, the AMSUC has become a premier annual event for members of the Asia-Oceania community. It serves as a platform to strengthen collaborative efforts in the utilisation of satellite data and products aimed at enhancing weather, climate, and disaster mitigation services. The conferences have consistently demonstrated their effectiveness in achieving several key objectives, including promoting satellite observations and identifying potential application areas with a focus on regional challenges, disseminating information on recent advancements in remote sensing science, fostering dialogue between satellite operators and the user community regarding current and future satellite missions, and finally, actively engaging young scientists in the field. And I'm very heartened to see so many young scientists joining us in the room today. The importance of the space-based component of the WMO Integrated Global Observing System, in short known as WIGOS, cannot be overstated, particularly during this critical time when the full impact of weather-related disasters is becoming increasingly apparent. Weather satellites play an indispensable role in providing essential data across various scales, from synoptic to mesoscale, and their historical records are crucial for assessing and monitoring climate change. It is imperative that we maximise the utilisation of satellite data as an integral part of the WIGOS framework, ensuring that its full potential is harnessed to address pressing global challenges. We are now confronted with new challenges and evolving needs from our WMO members. The year 2024 is on track to be the hottest year on record, with global temperatures temporarily reaching the 1.5 degree Celsius threshold above pre-industrial levels, as highlighted in WMO's State of the Climate Update. Greenhouse gas concentrations have reached unprecedented levels. Sea level rise is accelerating, glacier retreat is occurring at an unprecedented pace, and extreme weather events have caused significant loss of life and livelihoods in this region and across the globe. The recent outcomes of COP29 in Baku, Azerbaijan, while representing progress towards a new financing target, highlight the urgent need for more ambitious and immediate climate action. Addressing these challenges demands enhanced cooperation and the optimal use of all available observational data, particularly from space-based systems. The United Nations Secretary-General, Antonio Guterres, launched the Early Warnings for All initiative in November 2022 during COP27 in Sharm el-Sheikh in Egypt. This initiative aims to ensure that everyone on Earth is protected from hazardous weather, water, or climate-related events through life-saving early warning systems by the end of 2027. As the lead agency for Pillar 2 of this initiative, the WMO approved a comprehensive roadmap and action plan during its Executive Council meeting this June. I'll provide further details on this in my presentation later on. According to the agenda, experiences in utilising satellite data to support early warning services and climate action will be shared. The presentations will not only provide updates on satellite capabilities from operators, but also include insights on the application of satellite data across a range of areas. These include weather analysis and nowcasting, weather forecasting and climate monitoring, monitoring of thunderstorms and squall lines, landslide detection and mapping, near real-time wildfire smoke detection, volcanic ash dispersion observations, ozone measurements, and the monitoring of mangrove and urban forest ecosystems. WMO will continue to support this important event, and I am confident that this conference will play an increasingly significant role in fostering WMO cooperation. With these words, I would like to conclude my opening remarks. I wish to thank you, and I would also like to wish you all a successful and productive conference. Thank you very much.
Thank you, sir. Dr. M. Ravichandran, Secretary, Ministry of Earth Sciences, is a renowned scientist well recognized in the field of ocean sciences, meteorological sciences, and other allied subjects. I feel delighted to invite Dr. M. Ravichandran, Secretary MOEs, to address the audience.
Thank you. Dr. Nilesh Desai, Director of Space Applications Center, Dr. Alan Huang, Chair of this conference, Dr. Ben Churchill from WMO, my colleagues, Dr. Mahapatra, Dr. Sai Krishnan, invitees for this user conference, and colleagues and friends. Very good afternoon to all of you. I think this conference is very imperative in order to improve our weather forecast. And this conference is timely, as our minister told, that it is timely because this year is the 150th year of IMD is contributing to the service to the nation. And also it is timely because India has launched the new mission. It is called Mission Mausam. It is called Mission Weather. So considering those two aspects, I think this conference is very important and it is apt. So any weather forecast or any forecast, I think the important ingredients of improving the forecast is observations. Out of these observations, of course, both the in situ as well as satellites are very, very important. The contribution from satellites is immense. Though in situ is complement to satellite observation, both are complementary in nature, but the satellite observations are huge number of impact to the weather forecast. So hence the satellite observation is very important, and we need to know the nuances of the various satellite products and various satellites data availability and how to use it and how do we develop various mechanisms to ingest the data into the model. So of course, because this satellite observation not only important to have the impact, but also it is a global reach, because the weather phenomena in one place, what is happening, it is always impact other, the external forcing. So that will be able to resolve only by the satellite data. So hence it is very important to, in order to improve the weather forecast. And also we need to have the long-term, what is called the observations for having the climate related aspects. And second thing is this conference, it is a Asia-Oceania, and this region is having more diverse in terms of both spatial and temporal variability of weather phenomena. It is huge. So hence we need to understand the processes, not only assimilating the data into the model, but also we need to understand various processes much more detailed because of the clouds and other things always present in monsoon season. And this region also more frequent in various natural hazards like flooding, cyclone, and typhoon, and also we have a monsoon system, drought, and other and things so. So I think it is imperative that we need to have collaborate together so that we can bring out some innovation in terms of how we can improve our prediction system for the various weather phenomena, and also we need to make some best effort in order to exchange the best practices between the each countries and the region. within the region as well as without in other regions as well. And third aspect I want to stress upon is basically the current and future satellites. Of course, there are many satellites are available for understanding the processes as well as assimilating into the model. But at the same time, we need to go beyond, because as part of this various changes are happening in the climate changes. Now the spatial and temporal scales of various weather phenomena is changing dramatically, and many of these satellites is not able to resolve such a fine scale what is happening now. Hence, we need to go for much higher resolution in terms of both the temporal resolution as well as the spatial resolutions. And also, we need to go for much more than only 2D space than 3D. Of course, we need to have all the three variables, primary variables like a temperature, humidity, and the wind, not only at the surface, but we need to have entire vertical profiles so that we can always initialize the data with available satellite and other information so that we can go for better forecasted time step. And lastly, of course, for that reason, we need to go for, maybe we can, in this conference, you can think about how we can plan for the future satellites, whether we can go for geostationary or polar orbiting. Since we are very focused on tropical region, whether cloud related things, maybe inclined orbit, all these three things, how judiciously we have to use it and how we can resolve various processes and how do we utilize this data is very important. And what we need, also we need to have a recommendation for our region as well. I'm happy that we also need to, what is called, train our youngsters, especially early career researchers, for taking forward this aspect of weather into new innovation as well as the new domain, a new scale, how to improve our weather and climate forecast. Of course, there are many other tools which is available now, like AIML and other things, which we need to fruitfully utilize because the satellite data is very huge. I think it is imperative that we need to use the various technique like AIML and other things so that we in order to understand the processes better. Finally, I always stress on we need to have more and more collaboration in this area. As already pointed out, it is one Earth, one globe. I think we need to have the weather phenomena happens here, affects other places. Whatever is happening other places affects here. So we need to have, because anywhere, any location, it is both local as well as remote forcing effects. So we need to have more and more collaboration so that we can collectively improve our knowledge for better prediction, and thereby we translate science to services for the benefit of society. With this, once again, I thank you all for coming, and definitely this conference will pave the way for the future directions of the satellite utilization for the weather forecast. Thank you very much.
Thank you, sir, for enlightening us with your knowledge. Shri Nilesh M. Desai is a space scientist well known for his work in the development of NAVIC, microwave radar satellite, and third Indian lunar exploration mission Chandrayaan-3. He is recipient of many awards, including Lifetime Achievement Award for Accelerating Indian Design Verification Ecosystem by DVCon India. Currently, he is the Director of Space Application Center, ISRO, Ahmedabad. I invite Shri Nilesh M. Desai to guide us with his vision.
Afternoon, all the dignitaries on the dais. Honorable Minister has just left. Dr. Ravi Chandranji, Dr. Mahapatra ji, Dr. Alan, Dr. Ben Williams, dignitaries of the dais, all the dear participant delegates of this 14th Asia-Oceania Meteorological Satellite Users Conference. At the outset, let me welcome all of you, and also let me thank the organizers for giving me this opportunity to be here for this very important conference. And of course, also let me wish all the best and congratulate IMD on its 150th year, and also for Mission Mausam or Mission Weather, which Dr. Ravichandran and Honorable Minister also mentioned. And of course, some of you may be aware that our Navy friends are here. Today, India is celebrating on 4th December India Navy Day to pay tribute to the valor of our naval commandants during the 1971 war. So let me thank and congratulate, pay tribute to all of you, all your colleagues, because naval activities and weather and oceanic activities are very much related. Minister Saab gave us a very lucid account of all the activities which space has been doing to further the observations which will help the improving the weather forecast. So here let me begin with, in a lighter vein, on a joke. A lady was fighting election in India. So the media people asked her, "Okay, what gave you the inspiration to fight the election?" She said that, "I always used to fight with my husband at home and always used to win. So that gave me the inspiration that I can fight election and win." So same way, we had been observing, especially in my place, there is an astrologer called Mr. Ambalal. He used to predict weather in a very short manner. If he says it will rain today, it will rain today exactly at that time. So that gave us inspiration that why not we have a better technology or better observations using space-based satellite systems to help our weathermen to do better forecasts. And as Minister Saab says, statistics, although there is a media perception or perception in common man is that our weather forecasts are not that accurate. And of course, all of us know that tropical climate is very difficult to predict. And the strides made by IMD and our other colleagues are really remarkable. And ISRO is trying to pitch in with the technologies from space, which will improve the observations and which will directly feed into the activities which IMD does. So let me once again compliment and congratulate all the IMD people for doing great service for this country. Because reality is something different from what people perceive. And they have been doing remarkable job with their weather forecast and nowcasting system. So thank you, sir, for all your efforts day in, day out. As far as space is concerned, Minister Saab has already mentioned about some of the aspects. But let me just clarify, of course, ISRO has been famous in last couple of years with soft landing of our Chandrayaan-3 on Moon, South Pole. So people are obsessed with that missions like Chandrayaan, Mangalyaan, and now we are doing Gaganyaan and all that. But the majority of activity which we do, this is only 25% of our activity. The 75% activity is for the benefit of common man and society. That was the vision which Dr. Vikram Sarabhai, when he initiated India space program in 1969, that we want to use space research and technology for the benefit of common man and society. And this type of meteorological observation and ocean satellites are the major activities which ISRO does. And of course, we are increasing that. And as Ravichandran Saab also mentioned, okay, we are into discussion with improving our observation and having newer and newer sensors in satellite, which will aid into the various activities which they do. So almost all the activities which we do, 75% is related to satellite communication, satellite navigation, and remote sensing, whether it is meteorological observation or other Earth-related observations, which directly feed into the activities which help the common man and the society. And we'll continue to be our focus for all these activities. As far as weather-related aspects are concerned, we have been doing our bit with one is the ocean satellite, where we have put a scatterometer radar, on which personally I worked on that so that I can throw more light on that. So it is a pencil beam scanning scatterometer, which gives us the observations related to wind vector, which is a very important component into weather forecast. And we had large number of spectrometer satellites which have been put in space. Of course, at a time we have only 1 or 2 spectrometer satellites working, but the need of for our IMD department is that we should have observation every 3 or 6 hours. So we'll need a constellation of spectrometer satellites. And we are surely very seriously working on that with IMD and Ministry of Earth Science, that we should have a constellation of 4 or 8 such wind spectrometers, which will directly feed into the activities which of related to whether it is cyclogenesis and measurement of wind vector, which can be assimilated into NCMRWF models, which will really improve the weather forecasting and other capabilities. So that is one area where we had been working. Of course, when we were rejoicing at our soft landing of Chandrayaan 3, quietly we were pursuing the other activities related to the launching of INSAT 3DS satellite, which we quietly did on 17th February this year, 2024, where this is one of the latest meteorological observation satellite. INSAT 3DS was launched from Sriharikota, and it is a very advanced imager and sounding system. Of course, we are one generation behind the world level. So we are trying to catch up with that, and we are already in the process of defining our INSAT 4th generation series of satellite, which will catch up with the observation provided by Himawari or MTG or GOES and other satellites. So, but the INSAT 3DS capabilities and the problems we faced during our earlier INSAT 3D and 3DR, especially related to calibration, they have been overcome. And today we release the data products also, and I'm happy to pronounce that the product's quality has been really improved very well compared to the earlier products. And I'm sure that it will feed directly into the activities being done by IMD and Ministry of Earth Science. And of course, as I mentioned, INSAT 4th generation related discussions are already, mostly they have been completed, and we are into defining the sensor configuration, where we'll have a 16 or 18 channel imager with all advanced features similar to what Himawari and other satellites have, with hyperspectral sounder as well. And one other new activity has been the lightning mapper, for which there have been a lot of demand, because some of our parts of our country are prone to lightning observation. So we'll have a lightning mapper, which will have what Minister Saab was mentioning about newer technologies, that is neuromorphic sensing, which will help us to have a selective observations on various areas, which will feed into the activities which we are going to do related to vulnerability analysis, especially due to lightning, probabilities or chances of lightning in different areas. So that is going to be another new sensor in our arsenal. Of course, we are also working on various types of LIDAR systems, whether it is wind LIDAR or differential LIDAR. So that is another area which we had been working. And if not the couple of first satellites in INSAT 4th generation, the later satellites will have these LIDAR systems as well. So all these technologies we had been working on to strengthen our observations, and we will have more number of satellites into this category. And of course, all of you may be knowing that we started working on geoimaging satellite, that is having a surveillance system from geostationary orbit. Generally, all our imaging systems are in polar orbit, and it also has a what we call a GISAT satellite, which will have GISAT 1R is almost ready, and we are going to ship it to our Bangalore Center for integration with satellite. So that is going to be another sensor, which will again directly feed into the various meteorological observations, especially with this LWIR channel, which it will provide. So this is going to be another new sensor, which will directly feed into various activities which IMD does. So all in all, we have defined a very good program with futuristic and newer sensors as far as meteorological observations are concerned. We already have various OceanSat 3 series of satellites. So already OceanSat 3 is in orbit. Another OceanSat 3, which is a repeat mission, we are going to launch. Of course, it will also have a humidity sounder and a temperature sounder. So that again will feed into various activities of IMD and other MOES institutes. So that is going to be launched within next 6 months. So, and then we'll be defining again the OceanSat 4 series of satellite with newer sensors. And of course, Honorable Prime Minister has announced the launching of G20 satellite. Ministers have mentioned about the GSAT-9, which is South Asia satellite, where we are trying to help with communication capabilities to our neighbors. Similarly, we have built a Bhutan satellite dedicatedly for observing for the Bhutan country. Similarly, for Mauritius, again, we are going to build a satellite dedicated for Mauritius. So we are doing a lot of outreach activity as well. And this G20 satellite will be totally built by India with sensors from all the G20 plus the African continent. So G21 actually it is. So that also, again, will have sensors for mostly for environment monitoring and climate change related studies. So again, that will also feed into some of the activities of IMD and MOES. So all in all, we have a very good program for meteorological, oceanographic, as well as environment monitoring sensors in space. So which will directly feed into the activities which we are planning to do. And this conference has come at the right time in India, where you can deliberate on various aspects related to usage of these observations and improving the weather forecast capabilities. So with this, once again, I wish all the best to the delegates for this very important conference being held after a long time in India. And once again, compliment and congratulate the IMD as well as other institutes of Ministry of Earth Science for organizing this particular conference in India, which will give opportunity to our young researchers. And of course, ISRO scientists also get into insight into the various requirements of the users of satellites observation systems. So with this, once again, I wish all the best to all of you and thank you all for inviting me. Thanks.
Thank you so much, sir, for your inspiring words. Now we'll have a keynote address by Dr. Satya Kalluri. Dr. Satya Kalluri is LEO program scientist who provides critical support to the JPSS mission by leading the NOAA science team, guiding JPSS in the definition of low Earth orbiting science objectives. He has more than 25 years of experience in academia, industry, federally funded research and development centers, and the government. Dr. Satya is an expert in developing remote sensing algorithms, application, and complex satellite ground systems for Earth science missions at NOAA and NASA. I request the tech team to kindly play Dr. Satya's recorded keynote address on applications of satellite observation over Asia and the Pacific.
Namaskar. Good morning and greetings to AOMSUC on behalf of NOAA. I'm sorry I could not be there in person, but I appreciate the opportunity to give this talk about the application of NOAA satellite observations over Asia and the Pacific. Here's an outline of my talk. I'm going to start with a brief history of NOAA's LEO and geostationary satellites, and then proceed to highlight some recent applications of the data in weather prediction and other applications over Asia and the Pacific. In the end, I will close out with some personal thoughts on how we all benefit from using satellite Earth observations for science and applications, and also highlight some aspects of satellite data that are important for current and future missions. Here's a timeline of US and NOAA's history in operational polar orbiting weather satellites, beginning with the TIROS-N in late 1970s. And TIROS stood for Television and Infrared Observation Satellite. It was a prototype of the fourth generation post satellite that carried the AVHR that we all know very well. It also had a TAO sounder and a suite of space weather sensors, and we have come a long way since then in the past 40 years to where we are now with the current generation of JPSS satellites. On this slide, you see the first images captured by TIROS-1 satellite on the left. It was essentially a couple of TV cameras and video recorders. And on the right, you see images from the current JPSS satellite, which collects state-of-the-art Earth observations from the UV region to the microwave region of the electromagnetic spectrum twice a day. JPSS mission is part of the global backbone of observations that feed numerical weather prediction models around the world. 5 years after TIROS N satellite was launched, NASA and NOAA launched the first GOES satellite in 1975. And believe it or not, they viewed the Earth only about 10% of the time. And what this graph is showing is the timeline and evolution of different generation of GOES satellites in the US by NOAA. The satellites collected images in the visible and infrared bands. And now we have the GOES-R satellites with the advanced baseline imager that collects data in 16 bands. And different versions of ABI are also flown by JMA Simawari mission, as well as KMA's GeoComSat mission. These images show how far we have come since the first GOES satellite in the 1970s to the current GOES-R series. The image on the left is the first light captured by GOES-1 satellite. And the image on the right is the animation that we are so used to seeing from the current generation of the geostationary satellites around the world. JPSS is the current generation of NOAA's LEO satellite in 1330 orbit. Each satellite covers the entire Earth in 14 orbits twice a day, once at 1330 in the afternoon and once again at 1:30 at night. 85% of the data that is used in global NWP models comes from polar orbiting satellites such as JPSS, the EUMETSAT's METOP satellite, as well as NOAA's legacy POST satellites. At present, there are 3 JPSS satellites in orbit, with 2 planned for launch in 2027 and 2032. NOAA 21 is the primary satellite, NOAA 20 is the secondary satellite, and SNPP is the tertiary satellite. As you know, there are 4 different types of sensors on each of the JPSS satellites. ARMS is the ozone sensor, ATMS is the microwave sounder, PRIS is the hyperspectral IR sounder, and VIRS is the visible and infrared imager. Now I'm going to highlight how important JPSS satellites are for numerical weather prediction models. These are 2 graphs that show the improvement in NWP scale over time from 2 global NWP centers. ECMWF is on the left, and NOAA's NWS NCEP is on the right. While these graphs show standard NWP metrics such as 500 millibar geopotential height, etc., the main takeaway is that they roughly translate to about an improvement in forecast by about a day for each decade. In other words, today's 5-day forecast is as accurate as a 4-day forecast about a decade ago. This graph shows the improvements over time in hurricane forecasting errors over the Atlantic by NWS since 1960s to the present. And as you can see, the track error for a 72-hour forecast was over 400 nautical miles in the 1960s. Now it is under 80 miles at present. These improvements in NWP are driven not only by improvements in models, but also by computing power, and also by the large amount and type of satellite data that is assimilated into NWP. This is a recent summary of types of satellite data assimilated by various major NWP centers around the world. And as you can see, every major NWP center assimilates NOAA satellite data. This slide shows the impact of various satellite observations at 3 major NWP centers around the world: ECMWF, the UK's Met Office, and NASA's GMAO. As you can see, microwave and infrared soundings from polar orbiting satellites such as NOAA's legacy POST, the current JPSS, as well as EUMETSAT METOP are the top 2 contributors for global NWP, followed by AMVs from geostationary satellites and radio occultation from LEO satellites. Now let's see what happens when LEO satellite data are denied in hurricane forecast. Hurricane Sandy, or Superstorm Sandy, was a major tropical cyclone that made landfall near Atlantic City, New Jersey in 2013. It caused over $70 million in damage and was the largest Atlantic hurricane on record by diameter. ECNW models were widely credited for predicting the storm track accurately. And Dr. Tony McNally from ECMWF did some data denial studies after the hurricane. And as the graph of the storm track shows on the top left, the hurricane ends up somewhere over Maine if the polar satellite data were to be denied from the forecast. This shows how important the LEO satellite data are for not only numerical weather prediction for synoptic weather, but also for hurricane track intensity forecasts. Here is another recent experiment that we did at NOAA, where we added one observation type at a time to predict Hurricane Dorian, which was a Category 5 hurricane. Blue dots are conventional obs only. Pink is with radio occultation added, meaning the pink dots in line represent the track error when you add radio occultation on top of the conventional obs. Light blue is with infrared, and orange line depicts the hurricane track when you add microwave. The prediction shown in red is when you add all the data, and as you can see, the collecting power of all the data is more than any one single type of observation alone. Here is a JPSS VIIRS image of two recent tropical cyclones, Dana, that made landfall over India, and Trami, that made landfall over the Philippines simultaneously. Both these tropical cyclones caused tremendous damage over the two countries. This animation shows both the hurricanes as seen by current generation geostationary imagers from the vantage of KMA's GeoComSat 2A. An example of our latest generation of geostationary satellites, abilities to track tropical cyclones in 4K high resolution. And this collage of images shows observations from several microwave sounders and imagers. A 3D view from JPSS ATMS is in the center panel. Rapid imagery from INSAT 3D is the animation that you see on the right. And you can also see ocean wind vectors from OceanSat 3 at the bottom. These two animations show accumulated precipitation from tropical cyclone Trami on the left, and TPW, which is the total precipitable water for microwave sounders during tropical cyclones Trami and Conway on the right. In addition to NWP models, microwave soundings at NOAA are also used in a variety of tropical cyclone prediction products such as hurricane intensity and structure products. And I'm now going to show a couple of examples of these products. On the left are a collage of microwave sounding images from ATMS and AMSU, and on the right is the track of cyclone Trami. Now I'll describe how this data are used in hurricane intensity and structure algorithm, or HISA. HISA estimates the intensity and structure of tropical cyclones using satellite microwave temperature and moisture retrievals to produce maximum wind and radii of 34, 50, and 64 knot winds using gradient and nonlinear balance equations for 1D and 2D horizontal winds. This chart shows graphical outputs of Vmax, the maximum velocity of wind, and wind radii in 4 quadrants from HISA algorithm for Hurricane Trami. These are HISA outputs of wind speed and gradient at different pressure levels in the atmosphere. These are rendered as images, which are important for hurricane intensity forecasts. NOAA scientists are also developing a new extratropical classification type products for qualitative storm type diagnostic and situational awareness using HISA algorithms. Temperature advection and cyclone phase space parameters are used as predictors in the new extratropical classification types for qualitative storm type diagnostics and situational awareness. The next application that I want to showcase are examples of how satellite data are used in precipitation estimates, as well as the flood mapping that results after intense precipitation events. Between June and November 2022, over 1,500 people died and several thousands were affected in Pakistan due to floods caused by heavy rainfall that was several times the normal. AMSU and ATMS sensors from NOAA are part of the NASA's Global Precipitation Mission constellation, and the animation here shows the accumulated precipitation from NASA's IMERG system. These images from VIIRS show the extent of flooding over Pakistan. The image on the left was taken in 2021, and the image on the right was taken after the intense rains in 2022. As you can clearly see the extent of flooding due to this heavy precipitation events in 2022. Before and after rainfall, VIIRS reflectances are used to create operational flood products, as seen in this example over Pakistan. The VIIRS flood products are available via the International Disaster Charter and they are used by several disaster management agencies around the world. Next, I will show how LEO data are used for monitoring extreme events with some examples over Asia. 2023 was the world's warmest year on record based on data collected from in-situ observations around the world. The over 40 years of microwave soundings from NOAA satellites also measure temperature trends at different levels in the atmosphere, such as the upper and lower troposphere, as seen on the graphs on the right, and the stratosphere, since each sounding channel measures temperature at a specific height in the atmosphere. Based on observations collected around the world, so far, 2024 is on track to be the warmest year on record. Several countries in Asia and the Pacific region experience extreme heat waves, and extreme heat is one of the leading causes of mortality around the world. The image on the left shows global temperature anomalies from surface-based observations during April of this year. And the one on the right is anomaly in the lower troposphere from NOAA's microwave sounding unit, AMSU-A, and the current ATMS compared to a 30-year mean. As you can see, there is strong correlation between the two, and the satellite observations match the surface observations quite well. Here, you see 3 examples of extreme heat over Southeast Asia from NWP models on the left on April 30th, 2024. In the center, you see actual measurements from JPS's CRIS sensor and the monthly anomaly compared to a 30-year satellite climatology product that I described earlier is seen on the right. Notice how well the satellite observations captured the heat wave. Similar to the previous example, here you now see the heat wave captured by JPS's CRIS sensor for India during this year's summer on the right. You can see how intense the heat wave was this year compared to last year, which is 2023, that you see on the left. Having sensors that are well calibrated, sensors that have stable performance, and sensors that have long mission life is critical not only for operational NWP, but also for climate studies. As you can see on the graphics on the right, the NEDT and gain for AMSU on METOP-A has been stable for over a decade after launch, and we expect ATMS and JPSS to do the same, as you can see on the stability parameters that are mapped on the left here for NOAA 20. NOAA collates the WMO Global Space-Based Intercalibration System, or G6, and JPSS, CRIS, and ATMS are part of the global reference system for other LEO as well as GEO missions, as seen on the next chart. This is the state of the observing system, or SOS, which shows the performance of IR channels on Himawari 9, GeoCommSat 2A, and Meteosat second generation satellite, which are geostationary satellites, compared with CRIS and EASI IR sounders that are used as a reference calibration. Finally, we will see how BEARS data are used for monitoring biomass burning and air quality over Asia. Biomass burning is a leading cause of poor air quality around the world, leading to respiratory ailments that cause mortality and morbidity that transcends national and international boundary. The dual gain infrared bands of BEARS detect fires of low intensity, and this animation shows the seasonality of agriculture and forest burning over Asia during 2023. The BEARS Actifier products are produced at 375 meter and 750 meter spatial resolution, and they not only detect fires and their location, but also the fire radiative power. The fire radiative power can be used to estimate associated emissions from burning biomass across the globe. The BEARS image here shows fires over Thailand, Cambodia, Laos, and Vietnam on March 7, 2023. And here is a close-up of the image of the fires that you saw on the previous slide on March 7, 2023. This BEARS image shows smoke and haze on November 7, last month, over northern India, Pakistan, and Bangladesh from agriculture burning. And here's the BEARS fire mask for the same data. And now we will see how a variety of atmospheric chemistry product from LEO satellites on November 7th of this year. Here you see the BEARS aerosol optical depth seen by BEARS. And here you see CRIS carbon monoxide on the same day. And carbon monoxide is a good tracer to show which way the wind is blowing and which way the smoke and haze are spreading. And here is the aerosol index observed by Sentinel-5 Tropomi. And here is the ARMS aerosol index, again on November 7, 2024. As you can see, the variety of observations from multiple LEO sensors, from multiple satellites, when combined together, provide a rich and powerful set of observations for atmospheric chemistry. Now I'm going to talk about how we can track the reductions in pollution caused by lockdowns during COVID-19 as observed by our satellites. The COVID-19 lockdowns resulted in significantly less automobile traffic in many megacities of the world, leading to lower vehicular emissions, which significantly improved air quality, and it could be seen by our satellites. On the left is the average BEARS aerosol optical depth during 2012 to 2019 over Eastern China and Taiwan during normal years before COVID-19. And the image on the right is from 2020 during the COVID-19 lockdown. You can clearly see the reduction in atmospheric aerosols due to reduction in traffic when you compare the before and after COVID-19 data collected by BEARS. This chart shows the reduction in aerosols due to COVID-19 lockdowns in blue over major cities, and the bars on the right show where the AOD has gone up. You will notice that the increases are over cities that did not have a lockdown, especially in Taiwan that did not have a lockdown. One of the longest and most established uses of LEO data has been the use of vegetation indices such as NDVI for drought monitoring since early days of AVHR, and this application continues with current generation of sensors such as BEARS and is expected to continue into the future as well. Now, we cannot have a JPSS presentation without highlighting the unique day and night imaging capabilities of VIIRS, or the day-night band that can detect very fine light signals at night. The day-night band is unique only to JPSS. This band was originally intended for detecting fog and low stratus clouds at night for the benefit of meteorologists and forecasters, but has since spawned many innovative applications such as detecting power outages during hurricanes, tracking illegal fishing vessels at night, and studying urban geography, as well as looking at natural gas flares at night. A unique application of the VIIRS day-night band has been its application to detect and track fishing vessels at night that use high-powered light bulbs to attract fish. We can now use over a decade of VIIRS day and night band data to map human activity at sea and offshore development in coastal waters across the 6th continent. There are several ways of getting NOAA satellite data, which is always free and open. You could get the data at low latency if we have a direct broadcast antenna. You could get the data from NOAA's Class Archive. And now you can also get the data via Amazon Cloud Services, via Microsoft Azure Cloud, and via the Google Cloud Services as well. Finally, I would like to mention that you can read all about the wonderful applications of JPSS data through our annual Science Digest. You can scan the QR code to get a free online copy of all our annual Science Digest here. I would like to finally conclude my presentation with these key observations. Satellite data play a key role, not only in weather forecasting, but also in other environmental applications like how I demonstrated here. The contribution of different observations, such as microwave, infrared, radio occultation, etc., is incremental and additive to the NWP, meaning as you add these data, the collective power and impact is much higher than any one single type of observation. Sensors that have stable calibration and long mission life are important for climate monitoring as well as for NWP. Free and open data sharing of core data sets is important for weather and climate predictions for all nations, and NOAA is firmly committed to this principle. I would like to thank the organizers for giving me the opportunity to present, and I wish the AMSUC a huge success, and namaste.
Now it's time to express our respect and gratitude to the dignitaries on the dais. I request. Thank you, sir, for this. Thank you for presenting this video. May I request now dignitaries to come on the dais for the further ceremony? I request DJ Andy to kindly felicitate the guest of honor, Shri Nilesh M. Desai, by presenting him a memento as a token of our gratitude for sparing his precious time to grace this occasion and enlightening us with his wisdom. Thank you, sir. I further request DJ Andy to kindly felicitate Dr. M. Ravichandran by presenting him a memento for his continuous support and guidance. Thank you, sir. I request DGMT to kindly present a memento to Dr. Elaine Huang to express our gratitude for his guidance and support at international level for execution of this event. Thank you, sir. I request DGMT to kindly present a memento to Mr. Ben Churchill for sparing his time to attend this event. Thank you, sir. I request DGMT to kindly present a memento to the keynote speaker, Dr. R.C. Bhatia. Thank you, sir. Coming to the formal end of the function, I invite Head Satellite Meteorology Division, India Meteorological Department, Shri K.C. Sai Krishnan, to propose vote of thanks.
Good afternoon. Distinguished dignitaries on the dais, invited guests in the audience, our friends from the Ministry of Defense, our sister organizations, and friends. It's my privilege to deliver the vote of thanks on behalf of India Meteorological Department and the organizing committee of AOMSUC 2024. As we bring the inaugural session to a close, I would like to extend my heartfelt gratitude to our esteemed chief guest, Honorable Union Minister Dr. Jitendra Singh. Your inspiring address has truly set the tone for this conference. Your insights have broadened our perspectives and underscored the importance of collaboration and innovation in addressing global challenges. I thank Guest of Honor Shri Nilesh Desai ji, Director Space Application Center, Ahmedabad, for gracing this event with his presence. Your dedication to satellite-based applications and space-borne instruments serves as a beacon of inspiration for all of us gathered here today. We are deeply honored by your encouragement and the valuable time you have spent with us. It's my privilege to extend a heartfelt vote of thanks to Dr. M. Ravichandran, Secretary, Ministry of Earth Sciences, for gracing this occasion with his presence and delivering such an inspiring address. Your guidance has not only enlightened us, but also provided us with fresh perspectives to reflect upon as we move forward. I would also like to express our gratitude and a big thanks to you, Dr. Ellen, Chair AOMSUC, for your ongoing support and contributions to satellite meteorology. Your presence here today reaffirms your commitment to advancing knowledge and fostering international collaborations. Once again, thank you, sir, for honoring us with your presence and your thought-provoking words. We look forward to your continued support and guidance in the years to come. I express our gratitude and appreciation to Director General of IMD, Dr. Mahapatra, for his unwavering support and encouragement, which have added immense value to this event. Your commitment to disaster risk mitigation resonates deeply with our goals, and we are inspired to continue striving for excellence. Your leadership and vision have played a crucial role in the success of this conference. Thanks and gratitude to Dr. Ben Churchill from WMO for generosity in sharing your time and expertise. The passion and depth of your words have left an indelible mark on everyone present here. We look forward to staying connected and collaborating on future endeavors. A big thank you to all our delegates who have come from all different countries, made all the efforts and are here with us today. Participants, attendees, and all the persons involved in the preparations and successful execution of this event. Your enthusiasm and participation makes events like this meaningful. We hope this conference fosters fruitful discussions, collaborations, innovations, and a memorable experience for all. Thank you. Jai Hind.
Thank you, sir. In conclusion, As we begin this important conference, we encourage everyone to embrace the spirit of collaboration and innovation. Let's use this opportunity to share knowledge, explore new ideas, and work together towards advancing satellite communication. Thank you all, and we look forward to the insightful discussions ahead. Before concluding, may I request you all to stand up for national anthem. One minute. Let's all gather near the stage for group photo before proceeding for tea at ground floor. And thank you all. Once again, have a good day. Jai Hind. Group photo. All the participants, please come forward for the group photo. All the participants of this conference are requested to move forward towards the stage for the group photograph. Participants and invitees.
Yeah.
Now I will request everyone kindly check if you have a presentation in room number 2, kindly go to the room number 2 and only the room number, hall number 6 presenter will be here. So kindly check everyone, either your presentation in hall number 6 or hall number 2. So now we are going to start this session, Hall 6, the Space Program and Data Access Update. For this, the chair is Dr. Alan Huang, ICSC chair, and Dr. A.K. Mitra from IMD. And the rapporteur is Pankaj Kumar and Mr. Sibin. So I will request Pankaj, Sibin, and Dr. A.K. Mitra, sir, and Alan Huang kindly take your seat, and then we will start the session soon. The first presentation by JAXA Osamu Ochiai, recent update of JAXA Earth observation. And after that, the second presentation, overview of EW4 All Initiative and Infocom 3 work plan to address the gaps in satellite data products in support of EW4 All Initiative by Ben Churchill. So the first presentation is by Osamu Ochiai. I will request Osamu Ochiai, kindly come and start your presentation on recent update of JAXA Earth observation.
So, thank you, Dr. Niti. Now we are starting our academic sessions of the conference, in which the first we will ask recent update of JAXA Earth observation, Osamu Ochiai. So, yeah, so I request please you join the stage and okay, please come. Thank you.
So, okay. So, thank you, Chair, and good afternoon again, and ladies and gentlemen, namaskar. And I'm Toshiyuki Kurino of JAXA, and on behalf of Mr. Osamu Ochiai, I'd like to talk about the recent update of JAXA's Earth observation. So it's a great pleasure and honor for JAXA to have this opportunity to talk about JAXA's activity at Asia-Oceania Meteorological Users Conference. And thank you for the local organizer for the coordination. Oh, yes. This is a list of the JAXA satellite and some sensors in orbit. And as you see, there are 8 satellites and sensors. And I forgot to let you know, the JAXA is a R&D space agency like ISRO in India. And the JAXA currently operates 8 satellites. And as you see the, GOSAT and GOSAT-2, the greenhouse gas, and GCOM double water cycle, and GPM core satellite of precipitation. And AROS-2
disaster forest and land surface monitoring, and GCOM-C for cloud aerosol vegetation, and GOSAT-2, greenhouse gases. And this year, we have 2 additional satellites in operation. One is aerosol, the land surface monitoring, and another one is EarthCARE, the cloud aerosol radiation budget. And early next year, we will have another satellite, GOSAT-G. It is a very unique satellite, 2 missions, greenhouse gases and water cycle, 2 missions in one satellite, 2-in-1 satellite. So I'd like to talk one by one too. So first one is EarthCARE. And this morning session that Professor Nakajima introduced EarthCARE, so that's nothing to add. But it should be emphasized that the EarthCARE is a Japan and Europe joint mission to produce a synergetic observation of the cloud, aeros, and radiation. And, oh yes, and it is an observation example. And that by combining the JAXA's CPR, cloud profiling radar, and with ESA's sensors, radar and imager, and we can measure the cloud structure, particle structure, higher accuracy, which identified that contributes to better understanding of the cloud process. And yes, this is very important. And it's a conceptual figure. And the red part is only the LiDAR observed. And the yellow part is CPR and LiDAR both observed. And green part only the cloud profiling radar observed. That is EarthCARE. And this is the EarthCARE product structure and expected data release date. Level 1 data will be in public next January, soon. And level 2A, single sensor, will be in public March 2025. And the synergetic multi-sensor, level 2B, will be released a bit later, and the November-December period next year. So next one is a GPM. So the GPM mission, as you know, that by the Doppler radar, the 3-dimensional information, which cannot be detected by the passive microwave radiometer, can be very, very essential for the rainfall forecasting as well as disaster prevention. And actually, the JMA assimilated the GPM Doppler radar data in the mesoscale NLP model since March 2016. It is an example with the DPR data or without DPR data. The typhoon's forecast is dramatically different. Okay, and another the GPM is some the orbit boost. So that it is by this orbit boost from the altitude from the 407 kilometer to 442 kilometer. The purpose is to extend the mission life. By this orbit boost, the lifespan of the GPM core mission will become closer to the original estimation of ending in early 2030s. However, as you can easily imagine, that by the boost, the instrument footprint and source width increased proportionally with the altitude change, and the radar sensitivity was reduced slightly. Okay. So next is the GCOM-C mission. GCOM-C has achieved the initial 5-year nominal mission phase and now started the post-mission phase operation in January 2023. And GCOM-C enabled the monitoring of the variety of key environmental variables. It's with observation data from 19 channels of the SGLI sensor. JAXA provides 29 different products. So here I'd like to show you some example, latest GCOM-C product. It's on your left side. You can see that orange part is a heavy aerosol from the wildfire is observed in North America. And it's the left side. And the right figure shows the comparison of the snow cover between May 2022 and 23 in the Arctic area. The GCOM-C has observed a decrease in snow coverage in North America. It is also important to monitor the effect of the climate change. So next is GOSAT. Regarding the GHG or the greenhouse gas observation, the Japanese greenhouse gas observing satellite GOSAT, acronym GOSAT is acronym, was launched as the world's first GHG dedicated satellite in 2009. And since then, GOSAT has been monitoring changes in atmosphere, carbon dioxide, CO2, and methane, CH4, and every 3 days globally. And it frequently targets more than 50 large cities to monitor major anthropogenic emissions. And GOSAT-2 was launched in 2018, in addition to the same carbon dioxide, CO2, and methane observation as GOSAT. And it has a sensor capable of observing carbon monoxide, CO. So as I mentioned, Japan is a pioneer in measuring greenhouse gas concentration from space, operating the GOSAT series since 2009. This chart shows the decade-long global carbon dioxide concentration observation by GOSAT and GOSAT-2 from 2009 to present, to 2024. So data from GOSAT and GOSAT-2 is available on the several websites, including JAXA's website. And data is being provided to the WMO's World Data Center for the greenhouse gases. And the 24 academic papers using GOSAT series data were cited in the IPCC assessment report. I would like to take this opportunity to thank you all who are using GOSAT series data. So next one is it is scheduled to be launched early next year. GOSAT GW, and G for the greenhouse GHG observation. And the technology of the GOSAT series and being succeeded and upgraded with different type of gases to be observed and improving monitoring performance. Japan is planning to launch GOSAT GW carrying TANSO-3. TANSO-3 name of the instrument. The acronym of the Total Anthropogenic and Natural Emission Mapping Spectrometer. It's TANSO. In Japanese, TANSO means carbon. So it is a very, very nice naming. Anyway, TANSO-3 adopts the different type of the spectrometer, namely the diffraction grating type spectrometer. Previously, the Fourier transform type spectrometer, and a new instrument that increasing the new species, NO2 to observe. And also the in addition to the GOSAT GW, it has a 2 observation mode. One is wide mode, a spatial resolution of the 10 kilometer over the swath, at least 911 kilometer wide. And the focus mode is a spatial resolution that 3 kilometer over the swath, at least 90 kilometer wide. And next is a goes at G double. Double means a water cycle. And that's the successor of the advanced microwave scanning radiometer, AMSA series. Ish. And as you know, the series of the Japanese passive microwave radiometer with world best capability with fine spatial resolution by using the observation the 3-meter diameter antenna on board. And the same local observation time and similar the specification to achieve the continuous data set more than 20 years. And it will be 30 years by AMSA 3 on GOSAT GW. Data derived from the AMSA series have been widely used in operational application, direct assimilation into the model also, and also the water cycle and climate studies. So it's a talk about the future. Is a future plan data, the JAXA's PMM regarding the development and the operation of the spaceborne precipitation radar. JAXA has a long heritage TRIM and GPM since 1997. And on June 2023, JAXA precipitation measuring mission PMM project team was established internal JAXA, and JAXA will develop the KU band Doppler precipitation radar. And its contribution to the NASA the Atmospheric Observation System, AOS mission. According to the implementation plan of the basic plan of the space policy issued by the government of Japan, for targeting the launch in Japanese fiscal year 2028. So the JAXA's KU Doppler radar on board PMM will focus on the advanced observation of the precipitation, Doppler velocity observation, the high sensitivity observation. And of course, the international collaboration with NASA AOS mission will bring us the integrated understanding of the aerosol, cloud, and precipitation process with US and Canada to provide a mission to the AOS sensors. It also enhanced the mission value for the improvement of weather and climate model in context of international collaboration. This is my last slide. It is not a satellite, but the application product. As you know, that JAXA that's producing the Japanese precipitation product named the GS map. And using the GS map, the JAXA contribute WMO's space-based weather climate extreme monitoring. In this afternoon session, in session 2, I will talk about this this topic. And if you have an interest in that, JAXA's contributing to SWCM, and SWCM contribute, WMO's SWCM contribute to the WMO early warning for all data. Please go to the session 2 after the coffee break. Thank you very much.
Thank you, Dr. Osamu. It is very interesting talk, particularly the GHG and GOSAT. You have mentioned its past and then future also you have mentioned. Particularly, I'm very interested, particularly next generation PMM. So my first question is, now we are starting the question answer. So my question is whether PMM is, how PMM is will be differ than GMI or something? Okay, jointly they are developing it. Okay, so anything when it will be supposed to be launched, supposed to be launched and or something? 28. Okay. 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 Thank you. So anybody in the hall who's asking, who wants to ask any particular question to Dr. Osamu, please raise your hand. Yeah, please.
I had a question originally for was the EarthCARE. When I first saw the images, showing basically measurements of vertical cloud motion from space, I thought, wow. And my second thought was, when can we see it? Are JAXA contemplating of maybe releasing this information on a website? Yeah.
Next year, JAXA
Release the data. And will the data be in the visual format or will it be in?
JAXA data combined with the data and the visual data combined.
Okay. So it might be
usually, but that.
All right. Thank you very much.
Thank you, Dr. Osamu. Now we will go to the next speaker, Dr. Ben Churchill. The topic is, I think, is a very, very interesting because it is an overview of early warning for all initiative and Infocom 3 work plan to address the gaps in the satellite data product in support of the EW for all initiatives. I think last couple of years with the change of climate change and all this 1.5 degrees centigrade increase has made a concern to all, everybody, not only the one place, it is the entire world. So I am sure this talk will be very, very interesting for all who is working on weather and climate services or they wants to do something for climate research and all. So I request Dr. Churchill, please join the stage.
Good afternoon, everybody. This time I'm going to move the little stool. There we go. Now I don't feel so tall. Thank you very much. It's good to see you again. And as outlined, I'm Ben Churchill. I'm the director of the WMO Regional Office for Asia Southwest Pacific, and I'm just going to run you through an overview of the Early Warnings for All initiative and also the action plan from a regional perspective. Of course, this is a global initiative. Just as I'm introducing the topic, I just want you to reflect on this image, which is a nice graphic of how the world has been warming over the last decades. As we've heard this morning from myself and others, 2023 was the hottest year on record, and 2024, which is coming to a close, is well on track to exceed 2023 and be the hottest year on record. And the last 8 years have all been the warmest years. So we're really dealing with the climate crisis well and truly. So what I wanted to just reflect on with this slide is, and just to put this into context, the World Economic Forum meets from time to time, and all the senior economists put all their brilliant minds together and come up with the top risks over the next 2 and 10 years. What we can see over the next 2 years, topping the list on the left-hand side, is misinformation and disinformation. This is about many, many things, including weather and climate. And this is very disruptive. And we actually heard from the minister that, people sort of make this a hobby to sort of prove somebody wrong or just spread information that's not factual. And this is something we're trying to address. But when you combine that with extreme weather events, this is dangerous territory because people's lives and livelihoods are at stake. So this is a particularly big sort of red flag for all of us. In the 10-year period, we see the misinformation, disinformation coming down. Hopefully attempts to address that will start to take effect. But what we're seeing is all the environmental risks are really rising to the top there, and extreme weather is well at the top. So this is not just something that's happening now. This is something that's going to affect us for at least the next decade and decades to come, unless we do something urgently on climate action very soon. Another thing that's driving this with the global warming is what's happening with the cryosphere. So we're seeing unprecedented glacier retreat. We're seeing snow caps melting. We're seeing snow not forming, and we're seeing all of this water running into the water catchments and also out into the ocean. So this is driving sea level rise, but this is also a big issue in terms of water security and food security. And in some cases, some countries depend on water for their energy as well. So this is something that WMO is paying particular attention to, and this was put up as one of the key initiatives for WMO members just recently. So in terms of priority hazards in this region, we're seeing a lot of flash flooding. We're seeing droughts, extreme and extended droughts. Tropical cyclones are more frequent and intense. And you've also probably read reports about rapid intensification and forming closer to the coast, and also staying over land for a lot longer and dumping a lot of rain. All that rain that's coming up from the global sea surface temperature is basically going into the atmosphere and then playing out onto the land and creating significant damages in terms of floods and landslides. But we're also seeing stronger squall lines. And this is based on a rapid assessment conducted by WMO. You can see all the other risks there, but these are the top 5 that are affecting globally, but also these are playing out in the region as well. Of great concern to WMO and its members, and I think also should be concern to all of you and the global community, is only half of the world's countries have sufficient capacity to deliver early warnings to their citizens in the face of an impending hazardous condition. This was based on a global survey done by the United Nations Office Disaster Risk Reduction and WMO a number of years ago, which preceded the early warnings for all initiative, actually sort of triggered the action. And this is what we can see that is manifesting in Asia. I guess a key message here is that over the last 50 years, based on the WMO Atlas of mortality and economic loss, the globe has seen over 2 million deaths and about $3 or so trillion of economic damage. Half of this is happening in Asia and Pacific. So Asia and Pacific are the most disaster-prone regions and account for half of the loss of life and economic loss. And you can see most of the impacts, as we saw in the priority hazards, are coming from the heavy rainfall, the storms, the flooding, and so on. Of course, there are other impacts there as well. And just in terms of how this communication is important, over the last 4 years, we've produced state of climate reports for Asia and the Pacific and other regions as well. And these each year just run through the most extreme events and talk about the climate indicators. What they're demonstrating very clearly is that in Asia and Pacific, the land surface temperature, the sea surface temperature, increasing at a rate that is above the global average. So what we've seen over the last year or so, we're expecting this sort of information to appear in next year's report, is that we're seeing a lot more heat waves. We're seeing a lot more floods, a lot more extreme and prolonged droughts. We're seeing rainfall happening in places that haven't really seen rainfall for generations. I think the presentation earlier showed the rainfall event over the Arab Peninsula. Oman and UAE copped a drenching, and actually this closed down significant infrastructure in terms of airports. But here more closer to home in Bangladesh and India, we saw the tropical cyclone Ramal, heavy rain. Just pointing out there, and I'll come to an example later, but the loss of life is actually coming down due to early warnings. So 50 deaths is still too many, but in previous years, 10 years, 20 years, 50 years ago, we were seeing hundreds and thousands of deaths. So early warnings are very, very critical here. But the heat waves that we saw across all of the region, extending from Central Asia all the way to the Philippines, shutting down schools, impacting elections here in India, I read, so quite significant. Another key message, these are my key message slides, 24-hour warning ahead of an impending natural hazard is proven to reduce the impact by 30%. So that's quite significant when you're thinking of impacts of billions of dollars and GDP and lives and so on. This is a 24-hour warning. So if we can get better and better for every day, it's going to be even better than that. But this importantly saves billions of dollars annually. So there's a figure sort of floating around at the moment that for $800 billion invested in developing countries and early warning system, you can save $16 to $20 billion in economic loss. That's a big return on investment. So now I'm going to talk about the Early Warnings for All initiative. I think many of you may know about it. It's sort of become its own brand. of late, it was launched by the UN Secretary General Antonio Guterres in 2022 at COP27. It's being led by 4 pillars. I'll go through them very quickly. We have the United Nations Office of Disaster Risk Reduction leading on disaster risk knowledge. WMO, for the organisation I work for, is leading on detection, monitoring, analysis and forecasting of hazards. And then following the cycle around, we have the International Telecommunication Union focusing on warning, dissemination and communication. And a nice nexus between WMO and ITU is the CAP, the Common Alerting Protocol. But I won't go into detail on that, but that's how we get the messages out in a consistent and quick way. And finally, a non-UN agency looks after the 4th pillar. This is the International Federation of Red Cross and Red Crescent Societies, looking after community preparedness and response. So we all work together to drive this initiative. We have a number of focus countries that are getting sort of priority at the moment. 11 of those are actually in Asia Pacific, which is a good indication of where the highest risk and the greatest need is. And some of those are here in South Asia. So we have Bangladesh, we have Nepal, we have the Maldives in the Indian Ocean getting support. And I will just point out in the middle, there is another key organisation in the Asia Pacific, the UN Economic Social Commission for Asia Pacific, ESCAP, helping us deliver actions and strategies for transboundary hazards and supporting countries that aren't in the initial list. So that's it in a little bit more detail. I won't sort of dwell on that too much, but this just highlights who's leading on each. And also supporting that are a number of other partners. We have a number of initiatives like SOF and CRUISE, acronyms, Systematic Observation Financing Facility, looking after closing the observation gap across the world. And CRUISE is a climate risk early warnings initiative, which is a multi-donor trust fund, which is supporting particularly least developed countries and SIDS. So it's an all-in, very much a partnership approach, but it's also important to stress that it's being delivered at the national level. So it's a global initiative. We're pushing it regionally, but it's the countries that actually need to commit resources to this very important initiative and see the benefits. So here are the partners. I'm just going to put them up there for you to have a quick glance. This is more to just demonstrate we have so many partners. I couldn't even fit them all on one screen. Many UN partners, but we also have these financing mechanisms, the development partners. And I should mention here Green Climate Fund, World Bank Adaptation Fund, the regional banks like Asia Development Bank, very active in this space, as are bilateral partners, bilateral donors such as Australia through their aid program, UK, we have AusAid, we have many others, China, Japan, Korea, all running their own sort of support to drive this initiative forward. There we go. This is the example. I want to spend just a few minutes on this, just to really bring it home to you about the value of early warnings and how it really does work. So many of you who are sort of more local will recall that in the Bay of Bengal in May last year, quite a significant, in fact, it was a severe tropical cyclone developed, Cyclone Mocha, and it impacted Myanmar, Laos, PDR, Bangladesh, you know, with winds of 250 kilometers per hour, huge storm surge. Who was in the firing line? It was basically people on the coast, on the coastlines, some in refugee camps, very exposed, very limited shelter. So thanks to the India Meteorological Department, who host a regional specialized meteorological center, they picked this cyclone up many, many days, in fact, over a week in advance. And they sent this message to the Bangladesh Meteorological Department, but also importantly to the humanitarian organizations, the UN, OCHA, but also Red Cross and so on. We have this concept, which some of you may know of, called anticipatory action. It's about getting in front of the risk and putting resources in the hands of people, getting them out of harm's way, putting cash in their hand, giving them food, giving them supplies and so on, to basically anticipate the risk and try and reduce or mitigate the risk. So what happened was the message got out, resources were mobilized, the early warning messages were delivered 2 days in advance, people were evacuated to safety, cash was delivered, the communities were empowered to anticipate and mitigate the impacts, and also, importantly, to build back better after the impact. Now, the thing that's not on this slide is the death toll. And it concerns me that we don't talk about that, but I really need to emphasize this to really illustrate early warnings do work. So while we got hundreds of thousands of people out of harm's way, lives were lost. In this event, it was in the order of 100 to 150 or so. 10 years ago, a similar cyclone hit the same area, 5,000 people lost their lives. Wind the clock back 50 years before satellites were really sort of starting to come online. In 1970, there was a significant tropical cyclone, similar strength, Bola, 300 to 500,000 people lost their lives because they didn't have early warning systems in place. So I think you can see the trend there. So I think this really illustrates that early warning systems are effective, but they have to be effective for everybody, everywhere. So in terms of what we're doing in Pillar 2, this is the pillar that WMO looks after, we are trying to increase availability of observation data. Observations underpin all forecasts and warnings. The better the observation data, the better the warnings. It's quite a simple logic there. But also not just collecting data, but sharing it and exchanging it openly. It's critical. It feeds into our numerical weather predictions, which feeds into our models, and then we get better forecasts and warnings. We're also trying to increase capabilities, particularly in least developed countries and SIDS, but also in middle-income countries in terms of their forecasting capability for the priority hazards that I mentioned on an earlier slide. Impact-based forecasts and warnings are critical. So we talk about multi-hazard early warnings. We also need to understand impact-based forecasting is the best way to understand not just what the weather will be, but what it will do to people, what decisions need to be made to mitigate risks. We also need to strengthen institutional frameworks like policy and legislation, cooperation mechanisms, stakeholder engagement, mobilise more resources to ensure that we're focused not just on one or two hazards, but on a multitude of hazards in this multi-hazard concept. So in terms of Pillar 2, we also support other pillars. So we're not working in silos or in isolation. We're actually working very closely together. So we work with UNDRR very closely, also on the monitoring and evaluation of this initiative. Pillar 2 is also supporting Pillar 3, as I mentioned, with the Common Alert Protocol. We're also supporting Pillar 4 by working very closely with humanitarian agencies through the WMO coordination mechanism, which is working in partnership with humanitarian agencies to give them the information they need to have impact on the ground and protect society. And also at the inter-pillar level, just the sort of the mechanisms that work across, we focus on governance, partnerships, advocacy and awareness, so raising awareness of the importance of the National Meteorological Hydrological Services to their own governments, so they invest. Because remember, the investment gives the huge returns, right? So you need to invest. The planning, the financing, and I said earlier, the monitoring and evaluation. So we know how we're tracking and what else we need to do to fill the gaps. So this is just a snapshot of the cycle that we call the weather cycle, or the weather and climate value chain or value cycle. It's got many different names, but just very quickly on this one at the top, we see the observations coming into the system, top left corner, from an entire globe, from 80–90% from satellites. That's a very impressive statistic, but also from other observations, automatic weather systems and radars and so on. Exchanging those observations, feeding them into the modelling, and then that comes down into the services, more the service provision at the regional and national level in terms of producing the forecasts and warnings and advisories, delivering those products to the community, and importantly, making it possible to make good decisions, informed decisions based on the best data available, and in a timely and efficient and an actionable way. So in terms of early warnings in the Asia Pacific, this is where we are in terms of implementing. So I mentioned the 30 countries, 11 of those in Asia Pacific, they're all listed there. You can see some of your neighbours. We have many countries knocking on our door saying, can we join as well? So we'll have another 10 or so coming on board 2025. But at the moment, we've had a number of national consultation workshops. Each of these countries that have the workshops have made good progress on developing a roadmap, which is like an action plan. There are some in the Pacific that haven't started this process, but they're on track to start in the first quarter of next year. So it's just a snapshot of where we're at and the work that we still need to do. This is about the monitoring and evaluation, understanding where the money is coming from and how it's being used. So there's an initiative spearheaded by UNDRR and WMO to look at the whole picture globally in terms of investments coming from multilateral, from the big banks, the World Bank, the big funds, but also the bilateral partners that I mentioned earlier, to understand how much money is being spent on early warnings. And this is a really important piece to understand not only what is happening, but also where the opportunities are for further investment to fill those critical gaps. I might just skip over this slide. It's getting a little bit technical, but these are some of the programs under the different headings of weather, climate, water, and ocean that are actively implemented by WMO with its partners. And these are, again, just some of the financial mechanisms, but it's starting to get into a little bit more detail. But just here, all the flags on the right, these are the members of CRUISE that I mentioned earlier. So CRUISE, as I said, is a multi-donor trust fund, and it's about supporting capacity building for least developed countries and SIDS across the world. And it's very much aligned with the Early Warnings for All initiative. And just one thing I want to point out, it's many of these projects are scaling up with the demand coming from country level, but there's also quicker ways to get funding. So this accelerated support window has been very successful for getting quick, effective, impactful projects happening on the ground that align with the initiative. Just small funding up to $250,000 US, but some of the other big funds are following suit here. So Green Climate Fund is setting up a very similar facility, because one of the criticisms over the many years is that these big facilities take such a long time, sometimes 2 to 3 years, to sort of approve proposals and get the money flowing. So this is a good development. And then these are the other climate funds, GCF and so on. This is a little bit sort of internal mechanisms of WMO, so bear with me, but some of the things that we've done as a group. So WMO, for those who don't know, I work for the WMO Secretariat, which is a UN specialised agency focusing on weather, climate, water. We're only 350, 400 people, most of us in Geneva, some in the regions. The WMO as a whole is a community of tens of thousands of experts made up of 193 national meteorological hydrological services, and they make decisions to do things together. And some of the decisions that were made just recently, WMO roadmap was approved. We also have, at the regional level, we've had an early warnings for all sort of declaration made for RA2 Asia. We've also got the priority activities contributing, and some of these related things below are basically complementing. So we've talked about, we had some nice updates on greenhouse gas monitoring. That's another key initiative for WMO. I mentioned cryosphere. It's a high-level ambition across members, but focusing on those member states that have glaciers and have these sort of issues in terms of glacier retreat and glacier lake outburst flows and so on. And also drought indicators, climate data stewardship, state of the climate at global and regional scales. These are all initiatives that kind of add up to and contribute to implementing the initiative. So bringing this back to infrastructure again, which is what we're all here to talk about in terms of satellite data, but this is a key component of the infrastructure ecosystems that underpin the forecasts. We have to really focus on what's known as the Global Basic Observing Network. There are huge gaps in some of the developing countries, but also in our ocean areas as well. So we're trying to address this through a regional approach, which is the Regional Basic Observation Network. We also want to address gaps in satellite data and products. So this is why this exchange, why these conferences are so useful, to understand what is available in terms of products, but how they can be used. So getting that really active feedback is very important going forward. And analysing gaps and enhancing WIPs, which is sort of short, it's an acronym, another one, but it's basically the data that goes into the production of the forecasts, but focusing on products for priority hazards and also establishing support of regional centres, WIP centres, to support the developing countries. And cryosphere gets another mention there in terms of, well, it says emerging hazard, but cryosphere is a hazard that's here and now. We've seen what's happening globally. So in terms of regional coordination groups, WMO, as a facilitating organisation of the UN, working with its members, has established coordination groups. 2 minutes, thank you very much. To understand the satellite data requirements. So this is the way we exchange information on the needs and the users' requirements for specific data and products. It's a mechanism for coordinating planning, helping in terms of capacity building, helping those members that have lower capacity to have access to and use these tools. And these are set up and supported through the regional associations. So my office that I run in Singapore looks after Asia Pacific, and we support 2 of the 6 regions of the WMO, Asia and the Southwest Pacific. Now, there's a lot of information on this slide, so in the interest of time, as I've only got a minute and a little bit left, I might just allow you to have a quick glance at that. But basically, this is what we're doing in terms of at the work plan regional level, early warnings for all. These are some of the activities in a bit more detail in terms of what we're doing, how we're coordinating both internally and with our members to support early warnings for all. And another table, but there's a link here as well, so you can follow that when you get the copy of this. But this is the call on satellite products that are specifically helpful for early warnings for all. So remembering 90% of data goes into these models, this is a really huge opportunity. And so getting this right is critical. So just going back to my example about the Bay of Bengal and Mocha and Bowler and how far we've come in 50 years and everything else that I've talked about in terms of early warnings, I really want to stress that early warnings do work. They're a clear, proven, demonstrated, effective climate adaptation measure. They do work, but we need everybody's support, your support. We need partners' support. We need climate finance and donors to jump in. We need countries to get behind the initiative. We need that support so the early warnings can work for everybody. So with that, and I think I'm right on time, thank you very much for your attention. I'm happy to answer any questions, but I really want to thank IMD for this opportunity to present on this initiative. Thank you.
Thank you very much. It's very, very important for the South Asian country. So now, yeah.
First of all, very impressive initiative. I just wondering, like, one of the idea they made was very warning for the world. That's there. So, in order to do that, we have to understand engage with the CGLs. With the CGLs also
Yes, coordination group. Yep. Yes. Yep. Yep. I think first of all is to understand where the gaps are at the national and regional level. And this is done through the consultation workshops that I mentioned. So before we have those workshops, gap analyses are conducted under each of the pillars. And so WMO has some tools that we use to understand this. I think what you mentioned is actually the key next step. And so how do we engage with our regional mechanisms that are in place to get better coordination? Because we're not doing this country by country. The best scale to do this is actually sub-regional level, where you have common issues and common solutions, actually. So I think it's a really good point you make. We do have some big opportunities coming up, which I didn't mention in my slide. Regional association meetings. A meeting Asia is February next year and Pacific in May. And this is where we will have these discussions. So I encourage CGMS to really turn their attention to this initiative and work together with them, not just the members that are in the focus countries, but many members like developing countries, particularly where the capacity gaps are greatest, to see what we can do with satellite data to complement the initiative. Thank you very much. It's a very good point.
Thank you.
There is one slide in your generally And I think
I can hear you quite well, Annie, so. Oh, there we go.
Thank you. Yeah, so I think we need to also increase the capability of members in using the data available. So not only increasing the data available in the globally, I mean in for the members, but also increase the capability of members in using the data itself. So I think it's also very important to be added there in the outcomes. And there is another one question related to the I think almost last slide, before the last slide, about the regional coordination. Is it part of the regional coordination mechanism of WMO or the other?
I can explain both.
Okay,
Those are
thank you.
both very good point.
Thank you so much.
In fact, in many of the consultation workshops, some countries weren't even aware that some of these satellite products were available to them. For example, Himawari Car, some are sort of receiving them, but at a very basic level. So this is when in the roadmap, we have identified this as an action. And then we bring in partners to support that. And this is where the good point in CGMS comes in, because we could be doing this in a coordinated way, which takes me to your second question about regional mechanisms. So it is a global initiative, but the way that WMO is structured, we have our regional associations, and so we have to use those regional coordination mechanisms. In each region, we have a regional operating plan, which is like our action plan, and within that action plan, there are a number of actions which are decided by our regional members, and many of them relate to early warnings for all. So we can always update that with new concepts and new ideas. It's an iterative process and it's a dynamic process. So happy to continue these discussions in the interest of time, allow the next presenter to come on, but it's very much part of the regional process as much as it is with an overall global framework.
Yeah, just to that, is there any time for all?
Yes, there is. The UN Secretary General, when he launched the initiative in 2022, said he wanted everyone on the planet to be covered by early warning systems by the end of 2027. Okay, so this is very ambitious.
Yeah,
but it's ambitious because we have a climate crisis, and we have many other crises going on at the same time. We talk about the triple planetary crisis. Okay, but climate action is necessary in terms of saving lives and livelihoods. So we're doing everything we can to push towards that goal. If we don't make it, we will reassess at that time, and we may need to sort of keep going. But this is not a start and stop initiative, right? This is something that we need to keep doing in perpetuity. And this is why we need the national support and the national institutional mechanisms to really see this as a priority for national investment. And then we will continue to support by bringing in external donors. So yeah.
Yes, thank you. Thank you.
Yep. Thank you.
So now there is a next one is the online participant is there. From Soeb Salman. Is he available? Okay. Okay. His topic is a satellite derived flood product from optical and SAR analysis to support fact-based forecasting IBF and warning system.
Mr. Salman, are you presenting online?
Yes. Yeah. Can you hear me? Hello? Can you hear my voice? Hello?
Yes, it's kindly share your PPT.
Yeah. But can you hear me clearly?
Yeah, we can hear you.
Okay, thank you. Thank you very much. Oh, but now you can see my slide.
Yeah.
Okay, thank you.
So this presentation is S206. It's a hall number 2 presentation. So this Mr. Salman, he's presenting here. So this is for participants. Kindly note down, this is S206. Yeah, you can start now.
Yeah, thank you very much. Thank you for this opportunity. Thank you for the standing committee. Thank you for all the committee and participant of this conference. Thank you very much. Yesterday, I talked about flood monitoring with Mr. William. Now I will talk about a little bit satellite drive product, flood product from optical and SAR analysis to support impact-based forecasts and warning services. For the first time, I will start with introductions. Flood monitoring concept and collaborative work. So WMO initiative, like the previous presenter said before, we have to support with the impact-based forecast. So because in this opportunity, I want to little bit explain why we have to connect with each other, especially from meteorologists and stakeholders. Because in early warning for all, we have meteorologists, we have data, in situ data or remote sensing data, which is absolutely for the observation, and we have the stakeholder who get the impact and respond for early action. And we also have respond for a people and early action that will be connected one each other. And as the WMO guidance 2021 about the multi-hazard and impact-based forecast and warning services, also we can use the UCAMO document, the future of forecast. It will be connect each other. So I think the WM initiative, it's not only the meteorologists or scientists, but people and stakeholders have to work together. So about the impact and response in impact-based forecasts, weather forecasts not enough to prevent people from natural disaster. So we need impact analysis from each region. So this is very important and essential, because considering on impact on how stakeholder will respond it, give a warning and impact analysis. As a result, we can see the impact-based forecast. So because in the risk, we have hazard, exposure, and vulnerability. It's very important, because without the stakeholder, without the people, we cannot work together. So according to my last slide about the remote sensing and observation tools, optical and SAR flood products, it is very good for qualitative and high resolution analysis, especially for SAR, high spatial 5 to 10 meter resolution. So it's available for flood products, especially for NOAA flood products. And optical flood products overview about all the products provide flood area extents can be used for situational awareness, and the data available with the CFL output, GIS format, very helping for scientists, meteorologists, and weather forecasts to work together with the stakeholders. In flood products, we have 136 area of interest. So you can choose by your interest area. So this is very simple and very easy to capture your area, communicate with your stakeholders. So this is, for example, of rapid RSM 20-meter extent and deep map. And this is also the pre-operational development. So you can see this is very good example if you have the capability to use this data with machine learning or programming languages. And European fruit, for example, this year under development, but sure you can access this data. Yes. And also by utilizing drive flood product maps, one can create global or regional assessment. This is very important. You can stay awake for your product and communicate also with the people, with the farmers that need this data, so they can prevent from the natural hazard. And for example cases, international chapter in Pakistan, you can see also this is the static map, but if you can create the dynamic map using ArcGIS online or web-based map, GIS, you can coordinate with your stakeholder. So the result in discussion is dynamic map and ArcGIS online with the collaborative work with stakeholder we need, and it is very essential, because if we get the static map, you cannot collaborate, but with the dynamic map, you can add some stakeholder for work with you. So like this, in this case, stakeholder can directly draw the polygon of plot area. So weather forecaster produce the dynamic map or flood product, and stakeholder can draw flood product area directly in order to validate and communicate with meteorologists. So we can get direct feedback from them. So this is like they can validate and give the extreme event truly for the people, and how people can respond and action about the impact. And this is what we did in last year in Indonesia. So we gave our stakeholders, so we support us to draw polygon. So not only point area which impact and how to respond it, but they can directly to draw polygon, so they can give their perspective or they validate of flood prone area for flood monitoring. So that for conclusion, flood products is essential to support WMO initiative, early warning for all. Furthermore, impact-based forecast has been a method for meteorologists and stakeholders to communicate based on early warning and early action. And NOAA has been developing optical and sound analysis of flood products, so the product will be a good for qualitative, high resolution and analysis. In addition, flood product output is important to be considered in order to determine flood prone area, and by using dynamic map analysis, for instance, ArcGIS online or web-based GIS. So this is for additional information. If I can share this particularly presentation, you can download the data and process it in by yourself. So this is for example, and that's it for me. Thank you. I back to you, the moderator. Thank you very much.
Sir, any question for this presentation? Oh yeah.
Thank you, Rian, for the presentation. It's very interesting. As we also see, the from Ben previously, that the flood is one of the concern for the so I would like to invite you. After this, I will talk to you, and also Straka to have a joint collaboration for the training related to the utilization of the satellite products and analysis, flood analysis. Thank you.
Thank you, ma'am. Thank you. Thank you very much.
Thank you. So now we're going for the next presentation. One is not available. Is he available online? Okay, then we'll go to the next one. Then from GMA, Akiro Shimizu. Status of Himawari 8-9. Yeah. वो थे अभी? Just a minute. Okay, CMA is there. One But we have said we more than it is closed. Okay, will be there.
Yeah. Yeah, I checked it. So
Okay, so we will first have introduction to GK2A data service, KMA, Dayong Zion.
please open PPT again. Okay. Good afternoon, everyone. My name is Taegyum Jeon from KMA, and I'm going to present an overview of the GK2A satellite data services. Because of the limited time, I kindly ask for your understandings as I briefly explain the GK2A service. I will present about the general services followed with the data services. The GK2A satellite covers regions within RA2 and RA5 areas. Its purpose includes real-time weather monitoring and rapid disaster response to events such as typhoons, forest fires, and volcanic eruptions. This is the observation coverage of the GK2A. Let me introduce rapid scan service first. The GK2A's Advanced Meteorological Imager, or AMI, provides high-resolution imagery every 2 minutes, covering a 1,000 by 1,000 kilometer area, either in fixed or tracking modes. The fixed mode captures images of fixed coordinates, which the tracking mode captures images of coordinates that are requested for specific dates, adjusting to the relevant coordinates for each day. Since 2021, KMA has expanded its range to include not only the basic 16 channels, but also additional enhanced products such as color-enhanced water vapor and RGB composites designed for monitoring specific weather patterns like typhoons or volcanic plumes. For instance, during Typhoon Maisak in August 2020, ARS played a critical role in tracking the storm's progression and impact. Next, I will introduce GK2A Viewer. The NMSC website offers a high-resolution satellite image viewer that integrates with GIS and is tile-based. This allows for efficient visualization and analysis of large satellite images. The tile-based approach enables faster loading and real-time exploration of data at various resolutions. I'd like to talk about the data service now. Users can access GK2A data through various service categories, and I will introduce a few of these services. First of all, OpenAPI. OpenAPI supports L1B and L2 data in NetDef and PNG formats. Agencies, academic institutions, and companies can access data after signing up through the NMSC's website. The KMA API Hub is a central platform for accessing various data, including satellite, radar, and weather model data. The English version of this service is still under development, so in the meantime, we suggest using Google Translate until it becomes available. The hub will soon integrate the NMSC API service, which will streamline data access for both new and existing users. The NMSC website provides web-based downloads for GK2A and COMS data. Users can access images and data in formats like NetCDF and PNG. For GK2A, the platform supports both formats. For COMS, HDF5 is also available. This service offers a convenient option for retrieving satellite data without requiring specialized tools. Next one is FTP service. The real-time FTP service, or RFS, delivers full disk data every 10 minutes and local area data every 2 minutes. This service is vital for tracking hazardous events in real time. Please note that an account is required to access the FTP server, and data older than 7 days is automatically deleted. To address user-specific needs, tailored data products are offered through RFS. Instead of downloading the entire dataset, users can request data tailored to their region or event. This approach reduces data volume by about 90%, significantly improving resource efficiency. The tailored image product service is currently available to 4 countries, which is Fiji, Indonesia, the Philippines, and Sri Lanka. These products include various levels of processing, such as level 1B for basic scanners and RGB composites, and level 2 for aerosol detection, cloud parameters, and rainfall rate estimation. This service enhances usability by focusing on the specific needs of users. This is example of Fiji area. In conclusion, GK2A data services offer comprehensive solutions for real-time weather monitoring, disaster response, and tailored data applications. Do you have any questions or wish to explore this service further? Please feel free to contact us through the email or visit our website. Thank you very much.
Thank you for your presentation. I have a question. What are the data?
Available what? Only GK2A. Once again, question. Yeah.
Is it only the geo setup, or you have the other polar-based setup also?
Yeah, only the geo setup.
Okay. And what is the latency in the FTP server?
Latency. Sorry, I don't know right now. Sorry.
Okay.
I'll let you know.
Thank you.
Any other question?
Thank you for your presentation. I have an issue about what application they are familiar to analyze the data from GK2A. Thank you. What application that familiar for analyze GK2A image or data?
What applications?
Application for analyze. Level 1 or, yeah, level 1 data or imagery.
Or application? Software.
Yeah.
As I know, it's Python.
Mm.
Is that right? The language?
Yeah. For example, we use satellite for GK2A. What's application or software that we can use for analyze the data or imagery for GK2A?
Sure. We offer the software, anything like that, in the website, NMSC. So,
Is it for public or?
public.
Oh, okay. Can I know what's the name?
Okay. Okay, I know. Okay.
Any other question? Now one small announcement for hall number 2, Noah Mary Anand Kutti, BMKG Regina Dara Ningar, and CUST ISRO Hari Krishnan. Anybody is here? Okay. So now next in hall number 6, CMA NSMC Zhao Jiang. I think he's also not here. So the next one, Noah James. No. Okay. The next one is the GMA Akiro Sijamu. Now you can present, please come.
Hello, namaste everyone. My name is Akihiro Shimizu of JMA. Congratulations on IMD's 150th anniversary. Actually, JMA will also be celebrating our 150th anniversary next year. Congratulations. So, I would like to talk about the status of Himawari 8 and 9 and their follow-on satellite program. Okay, this slide shows specifications and the schedule of Himawari 8 and 9. Currently, operational satellite is Himawari 9 since 13th December 2022. So Himawari request service is international service. This service allows NHMSs to request target area observation conducted by Himawari 8 and 9 every 2.5 minutes. In regional monitoring, target area observation provides imagery covering 10,000 times 10,000 kilometer area every 2.5 minutes with flexibility for location changes to support JMA's national and international service. The observation is normally focused on an area of active volcanoes in the domain of the Tokyo Volcanic Advisory Center and is adapted to encompass typhoons within the responsibility area of the Regional Specialized Meteorological Center, Tokyo Typhoon Center. JMA also expects this service to support disaster risk reduction activities in the Asia-Oceania region. According to the latest status, 22 NMHSs are registered and 236 requests in 1 year. This slide shows Himawari follow-on program. In Japanese fiscal year 2018, JMA has started to consider the next geosatellite program, Himawari 10. And by JFY 2023, Japan will start manufacturing the geostationary meteorological satellite that will be the successor to Himawari 8 and 9, and to put into operation in account to around JFY 2029. So JMA will pursue seamless geosatellite system by considering CGMS baseline and WMO vision for VIGOS in 2040 to contribute to establishment of geo-ring observation. The current status, we are now manufacturing the Himawari 10. So in JFY 2028, the launch of Himawari 10 is planned. And start of operation of Himawari 10 will be Japan JFY 2029. This slide shows WMO vision for VIGOS in 2014 for GEO. This vision presents a likely scenario of how user requirements for observational data may evolve over the next 20 years. And an ambitious but technically and economically feasible vision for the integrated observing system that will meet them. In view of the vision, current Himawari satellite have only an imager, AHI. Regarding follow-on satellite, Himawari 10 plan to have a hyperspectral IR sounder in addition to an advanced imager named GHMS. Next slide shows the JMA's 10-year strategy toward 2030. JMA is aiming for improving Met service toward 2030 through technology developments, promotion of effective utilization of info data, then contribution to disaster resiliency. Regarding technology developments on heavy rain and typhoon forecasts, the observation of 3D humidity information will be very important. The hyperspectral IR sounder will be contribute to the observation. This slide shows JMA's effort for the stationary linear mesoscale convective systems. Stationary linear mesoscale convective systems bring severe high-impact weather events such as heavy rain, flood, landslide, disaster, and so on. JMA established a working group with external experts and internal task force to improve the prediction system to issue a warning with extended lead time by introducing advanced observation technologies such as GNSS receivers on vessels and geostationary air sounders and improving NWP models. So enhanced collaboration with academia is also important. So this is current situation of Himawari CAST. JMA started the Himawari CAST service, which disseminates primary sets of imagery via the communication satellite from January 2015. This year, 2024, Nepal has newly registered in Himawari Cloud service. So as we announced in AOMSUC 13, we are planning to terminate the provision service of LRIT and HRIT data with be terminated. But the specific date is not yet to be decided. To support users of the previous satellites, MTSat series, we have been providing these data as a temporary service until the preparation is completed of Himawari 8 and 9 data distribution via Himawari CAST and Himawari JDDS. So this is the Himawari 10. So this slide shows a follow-on satellite. Himawari 10 will have new payloads called GHMI and GHMS. GHMI is imager, and it is a successor of current imager AHI. GHMS is the first hyperspectral IR sounder in Himawari satellite series. In addition to imager and sounder, DCS and radiation monitors or space weather will be loaded on follow-on satellite. GHMI imager details are here. There are some improvements from AHI of Himawari 8 and 9. Target area slots for rapid scan will be increased. And new bands will be added, 1.3 micron and near IR, and 5.1 infrared water vapor band. Regarding 0.5 micron visible band, its center wavelengths will be shifted to appropriate wavelengths due to reflectivity for vegetation. These values are JML requirements, not actual values. Now this slide shows sounder GHMS specification. As sounders observation area, disk areas, Japan and target area will be planned. The observation intervals, as you can see, 60 minutes for disk observation, or 15 minutes for Japan and target area. The spatial resolution will be around 4 kilometers. The spectral coverage includes 2 zones, low and mid wavelength IR. The lower graph shows coverage spectral area for GXS, IRS, and CORIS, and also shows H2O and other various gaseous molecules absorption. But these values are also JMS requirements, so not actual values. This shows expected contribution of hyperspectral IR sound. GHMS is expected to contribute to significantly improving weather forecast accuracy through data assimilation. JMA prepared a simulated GHMS observation data set to support development GHMS data application in advance of its operation start. So thank you, Daniel, for your attention. That's all my presentation. Thank you.
Thank you. Quick question. One or two?
Thank you for your presentations. I have a question about to your GHMS Himalaya sounders. You mentioned the payload you use LC Harris new IR FTS sounders. So my question is, how do you expect the performance of the temperature and humidity profile of the Himalaya sounders?
Sorry,
my question is the performance accuracy of the temperature and the humidity profiles from the Himalaya sounder.
This is I'm sure show the values of the sounders. Accuracy will be this is not unclear for the because we are now manufacturing. Yeah. So in near future we can tell you the specific values. So thank you so for your question.
Yeah. Hari Krishna from No, he's not available.
Thank you.
So now, question. Follow. Now what? Oh. So now it is the Dr. Bodo, it's yours. So Dr. Bodo will explain satellite activity in Bureau of Meteorology. Thank you.
Okay, could you please put up my presentation? It should have my name on it, I think, and session 1. Is it there? I hope. Well, I'm ready. Hello. I have a piece of paper I can sort of show around. Have the same impact. So, yep.
Yogesh.
It should be session 1. Do you want me to show you, perhaps? Maybe the way I've written it is a little bit confusing. I'm going to improvise here. As an ex-forecaster.
Reason?
Confusion of whole layer. No, but
It's not in there.
Okay. But Speaker Alan, will he be available? Okay, so can we start the Dr. Alan? Yeah. So now I request Dr. Alan, sustaining contribution and sharing the responsibilities for the United Weather and Environment Satellite Observation for all. Dr. Allen.
I can use your time, right? You can use your time, huh? S108. Okay, all right. Well, I have a big title, okay? It's try to inspire all of us. I'm going to contribute very small portion of it with this umbrella, sustaining contribution. That means you don't stop tomorrow. You don't stop 10 years from now. You want to keep it going. So that's what we are committed to do because we want to share with you our contribution forever. Okay, so for unified means we put together everything. So whatever we do, we are not geared to one program. Japanese JAXA, JMA contribute many programs, many sensor, beautiful data, KMA, CMAs, and India, Israel also contributing, United States, Europe. We want to unify them, put them all together with same tools, able to have provide consistent, persistent view of everything. So I'm, of course, focused on satellite observation only, including weather and environment. So meteorological observation have these two aspects of information contents. Okay, so I'm from Space Science Engineering Center, home to the father of satellite meteorology. Very proud of it. Mitra visited us 2010, and many of us may be already visiting us. So you are welcome to visit us. We consider the father of satellite meteorology, and we are all the offspring, the children's. So we can go there to worship our building. So let me go quickly move on. So I'm going to include covering certain aspects of this contribution. We need contribution from satellites. Okay, this includes Europe, US, South Korea, China, Japan, India. Okay, and so we don't limit it to one country's contribution. So how can we produce something is long-lasting, unified, and consistent? Okay, through the data reception and processing. So the one way to get the data very quickly is through we call direct broadcast. Okay, every single measurement have scan line of measurements. We quickly send one scan line of data done. Reason why is reduce the latency. So you could get one scan line of the measurement in your fingertip while they are scanning the second line. So we don't want to wait. And while they are scanning the second line of the data, we processing the first line of the data through real time, okay? And we need algorithms, model, and software. We need to cover low Earth orbit, geo Earth orbit, geostationary Earth orbits. We want them all, okay? So we want unified. And we have this package, CSPP. So you go home today, you forget CSPP, then it will be my fault not to emphasize that's enough. So remember, CSPP is University of Wisconsin contribution. Sustaining this contribution, I want to share with you. We have our responsibilities. And so your responsibility is what? Using it, benefiting yourself. So I'm going to concentrate on why, how CSPP can help you. Of course, we want to know applications. It's not limited to one. It's not just flag. It's not just air quality, not just for pollution, not just for aerosol, not just for dust or smoke. We want to have a disaster component of it. So the early warning for all, CSPB can be a workhorse for all of you to use it. So now we contribute indirectly to the early warning for all from the component that we provide these products, this software capability. And of course, we will be able to cover severe weather because we can produce instabilities, rainfalls, wind information, fire, drought, all of this. And weather, important part, precipitation, instability, temperature, water vapor profile is also the workhorse for the NWP to use it, or you can use for nowcasting purpose. So again, Vern Sumi is father of satellite meteorology. I study under his students, William Smith, Dr. William Smith. Dr. William Smith is considered the father of satellite retrieval. So I have grandfather and father. If I say anything wrong, if I am not correct, it's their fault because they teach me well. Okay, so I'm just joking. Okay, so and then under SEC, we also have Cooperative Institute for Meteorological Satellite Study is under NOAA sponsorship. So we have ongoing sponsorship from NOAA. NOAA put up the efforts, allow us to do this service to you. So we like to thank NOAA for their continuing support, and they have a big heart. United States want to help all the peoples, despite of our political differences. Again, NOAA, on behalf of USA, want to help the global community so that we can do better, okay? Protecting our life, benefits society. So under SSCC, the processing side, the distribution side, data distribution side is very obvious. We already see this morning, the keynote speakers using our tropical cyclone teams, wind speeds, those vorticity displays, all those imagery over your Indian Ocean regions. And we also see some other people using this lightning cast, like Bodo talked about. They use our database, use our software. So we have the goals to continue to do that. And we are one of the world's largest nonprofit, non-governmental Earth Center for Geo and LEO satellite receiving, processing, dissemination, archiving. So some of the data you need, probably we have it, okay? So working with us, we can support you to do any historical data set and everything. And the most important part, if you want to go to AI, ML, you want to use historical data, we have it. We can help you out in order to have a long history of the data, the big data, and with consistent high performance, then your AI, ML will provide best training. Okay, we have satellite sensor, we build sensors. Okay, Himawari 10, YASI sensor, Chris sensor is based upon our design when I was studying for my PhD degree since early 1980s. So we know algorithm by heart. We know sensors principle by heart. FTIR, Fourier transform infrared spectrometer, we know very well. So we contribute sensor, we know the performance, and we develop algorithm, retrieval algorithms. Pratik from Israel, like he studied with me, we together developed retrieval algorithm for worldwide distribution for your Indian optimizations. And in science, we do apply a lot of science. We have a lot of students and professors and application expertise. So the most important part is when satellite produce digital counts, we could use, I'm going to talk about it, is end-to-end processing. We receive the data through direct broadcast, through netcast, or through the way from the cloud system. You go remote access to the cloud system from JMA storage, from KMS storage, from CMS storage. They have, yesterday they talk about how they can stage the data for you to use. And then you can use your own processing package, optimized to your own local situations. You can change the code. So you can convert the level 0 data receive raw data from satellite sensors and send it down to Earth. We quickly navigating, calibrating, geolocating them to produce level 1 data. And those level 1 data represent energy information from visible, near IR, IR, UV, or long wave IR, and microwave. Quickly can go into their simulation system. So from RDR, we can produce SDR, and SDR can go to their simulation system. The SDR, sensor data record, can produce EDR, environmental data record products, soundings of temperature 500 millibar temperature, low level water vapor at 750 millibar, surface skin temperature, ocean temperature, visibility, instabilities, or you can get that EDR. And information data record, you combine many products together, you can get information, okay? So all this, and we have designed the largest high performance computing system for large domain, high resolution weather forecast. We conduct, actually, no, we operate the operational NOAA's NWP models as we need to, okay? So we mimic operational scenarios so that when there are any improvements, we could quickly be able to port it to NOAA for further implementation for improvements. And we, of course, we offer remote sensing training and education seminar. I've been teaching a course around the world, maybe more than 12 workshops. Each workshop lasts 5-6 days, and it's very intensive, okay? One time I lost my voice for 3 months after a week-long seminar because I talked too much, okay? That's the downside of it. So we have a lot of antenna, C-band, L-band, X-band, XL-band. This is our infrastructure. So we want to contribute our technologies, archive as a sustaining efforts in my title of that presentation. So I really appreciate SSCC have this capacity. I'd like to work with you. So we have this infrastructure. We have the largest data bank for you to use. And we also, on behalf of NOAA, operate direct broadcast. Each direct broadcast can receive certain cone of coverage. That's the magenta, the gray magenta area. No, gray, cyan color. But so you can see in the Guam area, you have antenna. The Honolulu is all other area. We combine them together. So even we just cover regional, but at the Miami, for example, you can get Guam data if you want to, near real time, millisecond of differences. And quickly you can use the local software to produce whatever you need. So you call this near real time. So through direct broadcast network operations, we can get more than regional data extending to certain Mary area. Okay. Oh, all right. Now is the key. A project comes at a certain key times. CSPP is our contribution for sustaining these efforts. So CSP means Community Disaster Processing Package. So tomorrow I'm going to have a quiz. What is CSPP stand for? If you get a good right answer, we give you a gift. Okay. All right. We have a collection of software for processing many different type of sensor over different type of satellites come from SUMI MPP. That's one of the LEO orbits and NOAA satellites. METAP, that's European EUMETSAT ABC. A is already passed away. And then we have NOAA current satellite, and including Phone-in 3DE. And I forget to put geostationary as well. And the goal is to receive satellite data via direct broadcast, quickly create level 1B data and higher products, SDR, EDR, IDR in real time. And it's funded fully by NOAA JSS program. We already invested more than $50 million, okay? And direct broadcast, I want to skip everybody know the acquisition data with the lowest latency and do local processing for regional application. Okay, here, so, okay, this is one when it's data directly about $250 million, $250,000. Okay, they have a small version of it. This is the one way for you to get real-time data. One way, okay? And if you want to have a account logged into the TV network, you still can get some of the real-time data. So we will, because we want to share. Okay, CSPP is freely available software to process most of the LEO satellite data and GEO as well. Okay, we can calibrate observations, geophysical derived product, mapped images. CSP including visualization systems that could create automatically all the PNG files, JPEG files, using common standard input, CDF file, buffer data, all common data that used by NWP Center buffer data. Okay, all the satellite data in certain formats. Okay, and okay, again, and if you go to this website, you will see. So how is that being used? Currently, I should update it by this year. They already have more than 3,000 users in 180 countries, 108 countries. Okay, I wish next time I can say it's 180 countries, or you can see distributions. Okay, this is the core of CSPP. Okay, one chart, very complicated. I'm sorry, but I want to let you know that CSPP can process satellite, including SUMI MPP, NOAA 20, including 21 now, Terra Agua. Okay, that's NASA satellite, including MODIS. Everybody using MODIS, MSU-A and MSU-B. Okay, we used to have Brazil contribution called HSB. Okay, but that is just not functioning anymore. MECTAP BC, that's current operational LEO satellite from UMISAT, Chinese FY3C, 3D, 3E, and GOES, we including geostationary, and Himawari. You can use CSPP to process Himawari along with the GMA already have a certain product, but you have a certain ways that you want to have a consistent data with others. Oh, so you can process, calibrate your different sensors, including ABHR. ABHR have a long-lasting things, exist since early 1970s. So you have 40 years of historical data records, okay? And you can reprocess them using the latest ABHR processing, so you can get the best kind of consistent. There are no gap from one sensor to one sensor. So you have best 15 years of data. That's very rich for tiny study. VIAS data. MODIS, AIRS is advanced infrared sounder grading 2,000 some channels, grading spectrometer, MSU microwave. ATMS, the current generation of advanced technology microwave sounder, have 22 channel, is rich in surface temperature, soil moisture, precipitations, clouds, the temperature sounding, water vapor sounding. CRIS is current generation of FTIR, Fourier transform spectrometers. Okay, have 1,600 channel. YASI have 8,000 channel in each footprints. This is a classical European contribution for the highest possible infrared spectral regions covering from the short wave infrared to mid wave to long wave infrared without gaps. Will give you best temperature, water vapor, trace gases, CO2, CO, and all. And MERCY is one of imagery of the FY3. Okay, and ABI is the geostationary advanced baseline sounder and lightning vapors, GLM. So you can use this software to process, to produce lightning vapor, lightning information, and AHI advanced Himawari images in this sector as well. So you can process this many sensors, producing many products, including the most favorable product, RGB imageries, a different permutation, highlight aerosols or highlight dust, or a different color scheme to bring up different features of the phenomena you want to see besides cloud, low-level cloud or water phase clouds or all others, or low clouds distinct from the high cloud. And of course, the cloud information. So I'm going to show some of the example profiles, trace gases, land surface temperature, sea surface temperature, aerosol, dust, fire, flood, others. William and Rion show they show the flood is using one of the algorithms here to produce that. And of course, some other application that we go directly to air quality, aviation safety. That's another level of processing applications. And then this is a software package. So CSPP is just a name. Underneath, you have so many packages. You have a choice. You don't need to do them all. Okay. For example, you want only cloud, you select CleverX. They're producing all type of cloud. I'm going to show you some example. If you want to use profile, temperature-based sounding profile with the accuracy of 1 degree RMS at 1 kilometer layer. That's very accurate. 1 kilometer error of temperature from these products, from this sounding product, using new CAP, NOAA unique atmospheric processing system, okay? And then we have another profile retrievals using single field view, high spatial resolution, using multiple regression approach. And then we have a profile of clouds and precipitation using MERS, okay, microwave integrated systems. And all SST, all sensor producing very unified SST at the accuracy of better than 0.5 of degree. So the SST will guarantee the highest accuracy closest to half degree of error. Okay, and flood, fire, and then with traditional legacy IAPP international ATAP processing package. That's all sounders. And I have a geostationary as well at 4. Okay, and some others. Okay, so that's a product. In addition, not just producing product, we give you tools to do map projection. You can do from different map projection. The higher latitudes, the polar regions, projection on the equator and the mid latitude quite different. So we can do different map projection to give you Mercator projection or Lambert projections, so that you can see it appropriately and interlace with different product as same projections. So you convert them, then you can put them together. So 1 pixel that you could have multiple of information content to give you more rich of information. And then we could have software that Scott already talked about in the training session in detail how to take advantage of polar to grid, and the other one is geo to grid. That's a geostationary, that's a polar. The same thing that you have the scripts of information you can convert easily from different type of data, give you consistently. And then you can do a Python scripts that automatically generate everything for you after you got figure out what's the combinations. All right. And visualization system for teaching. I use Hydra to teach. I can visualize 1 pixel of the VS data or quiz data and display its spectral signature. And display is related products in different pixels. A dry region, cloudy regions, or cold region, and then we can intercompare how the algorithm function, how the measurement give you the information from satellite point of view. And then we have real Earth. Bodo mentioned the real Earth is a GIS-based visualization system. Allow you to put hundreds of layers of information. That's too much, okay? Including geospatial informations, plus all those products that you can overlay together. So you become a powerful visualization system, okay? So we have 2 types of visualization. It can help you to produce beautiful color composite images and all other map projection, along with real Earth, combining the geospatial information, have high topography information and everything else. all at your fingertip to produce. Okay, all these are tools are freely available. I have another page that you can do. Okay, and you're welcome to copy my PowerPoints to use whatever you want. Okay, all right. This is just some product, CSPV cloud product. Produce a cloud phase in the top left, cloud height in the top right, and cloud optical depth in the lower bottom. Right, just examples. Just a few days ago, we used UI regions that happen to have this orbits. This is one of the university have this direct broadcast system in Shanghai. And we use that. I teach over there how the satellite will benefit you, how the satellite producing the products that you can do research, you can improve it, you can do air quality, you can fit into NWE model some of the product or some of the data, so you can do a better job in forecasting that area. Okay, so it's just an example. And this is the gases informations, trace gases. Using CSPP new cap sub-package, you can produce this trace gases product, including CO in the upper left, CO2 upper right, and methane and H2O, or vice versa. Okay, you have the labels. Different trace gases, you can produce this all in near real time. What I mean near real time is less than 30 minutes. Some are 15 minutes. And another trace case, another example is SO2. That's very important for air pollutions. Okay, have a different compositions. N2O, okay, HO, HNO3. I cannot advance it. Can you help? I don't think I lost. Oh, good. Okay, don't move. Okay, so this is another classic example of producing something. Oh, you delay more of moving. Go back. Go back. Okay. Okay, don't move. Wow, okay, I move one more already. So you can see the temperature. The classical meteorologists like to display skew T locality. I have temperature in red. The dew points in greens, you can produce different pixels. This is skew T log P, very classical one. You can have the true color image, I call shadow color image. You have H, LD information, all in your fingertip when you produce this. You move the cursor to any points, you immediately display all these contours. Okay, and then you have other images to support you to interpret. Okay, and clouds. CSV producing lots of cloud products under CleverX. This is for geostationary. This happened to be Himawari images. Okay, so you can produce clear, probability clear near surface cloud, water level cloud, supercool water, opaque ice, everything else. Overlapping cirrus cloud, deep convections. That will give you a treasure trove of information that you can have to understand the weather phenomenon. Oh, I have a movie look too. So it's the shadow color, cloud types. We have a different type of clouds and label overlay of a different color representing a different thickness of cloud optical depths. This comes from the Himawari 8 example. And then again, shadow color, true color, cloud top temperature, cloud top ratios, all can be displayed in high frequency, high tempo for you to help whatever you do. Okay, I'm going to give a summaries. CSV can be your best tools for satellite product generation. We are going to continue these traditions of sharing our responsibility, sustaining our contributions to help everyone else along ourselves through the funding of NOAA committed to the long term to help our satellite meteorology community, okay, to do it. And this is the site. You go there, you can get this downloaded and install it. And we have, that's yet to come. We have users meeting. You can come to a users meeting complaining about, oh, this software don't work. This software is not good. And then we'll take that negative or positive comments to improve it. And we have this every 2 years. We have this users group meetings. And better yet to come, our next meeting will be in Guam. That Scott already showed. from 1 to 3rd of April, and we welcome all of you to participate, to use this. You are newcomers, no problem. You go there to learn. You are the all-comers. You have a lot to contribute, a lot to criticize us. We welcome and I'd like to hear from you. Thank you so much. This is our contribution for sustaining the contribution, sharing the responsibility through CSPP, one of our efforts. Thank you so much.
Thank you, Dr. Allen. I think it is a very, very important. You have just opened to all the beginners, because when we were beginner, and when I came there first time, so the data set was the most important part of how, from where we can download the data, how we will process it, and then retrieval scheme. So what kind of retrieval scheme could be utilized? And I'm thankful to year 2010 when we visited Wisconsin. Instead, 3D retrieval were the points where we were very thorough discussions and all. And so now here, as you have mentioned, that CSPP, and whether it is available freely to all the users. Okay. Mhm. Yeah.
Changing our contribution.
Yeah.
We don't go. If I retire, I still have 50 people's contribution. So we are here to stay for long term. Your investment will last a long time. Tomorrow, you won't disappear. So
I think that's a very good part of it. And then we have also mentioned that the AI/ML technique is also being used. That's great. Okay.
this side or this side or center, all different.
Okay. Yeah. Thanks. So, yes, just to the player.
Group director in charge of everything. So we are a sacred place. We go there and we can there. So,
Thank you, Alan. Thank you. So this is a part of your capacity building that standing here. So regarding this direct broadcast, CSPP program should direct broadcast system. So this one, you have the system here, and so this one antenna system, direct broadcast, of this one. It's all for all the satellites. Yeah.
Imaging, soundings from visual and geo, and some of them.
Yeah.
So just all major. One more. Okay.
Yeah.
But it's just that's this is a most of the people like to do this.
In India, is this
when you have your Indian carbon data,
yeah,
sensors,
yeah, right.
generate that. You can generate global product anywhere. Depends on where Yeah, I can show another case from Miami, from the River or Tuan. Okay, so again, the inputs, your input below the data, you produce a product for that area. So.
Is like image cast. We have all this data available, all the satellite data, L1. Yeah, we can. So how much will be difference? Imagecast also these days near real time it's available.
How fast you get the data.
Yes, yes.
Our processing is quite few minutes. So all our process is highly parallel.
Right.
Using interface, using multiple core of CPU. Okay, and you can even run GPU. I have another model. GPU-based work model can run 500%. What they are doing is making data and you can watch it how it's populated. This is
And this to reduce the time latency in our regional coverage. But
Next, the work in your yes.
Oh. Every example, crease sensor, or gear sensor, or the wet tap sensors, all have drifting. Sensor is built to depend on space, environment, and change the age impact. Their calculations will be changed. So we have the updates. When we see anything that needs to be recalibrated using input different parameter, different offsets, okay, we will immediately. The NWP, major NWPC center, always monitoring any abnormality of the measurements. That is not best calibrated. They will alert us, and we will using the updated coefficients to quickly update it. When you register, we will there let you know. The new version provide the best calibration. Much random noise due to calibration issues. So you will have the benefits of staying on top because we know we are monitoring it. And that's why we have these updates. We have this.
Have a discussion. Yeah. Yeah, thank you. So we are running out of time. Now I'll ask Dr. Bobo for his presentation in BOM. Thank you. Quick.
Time already, so I won't go over that. Okay, and so operate this standard. Does it have a little light pointer there? No, it doesn't. Oh, maybe it does. Yes. All right, good. All right, I'm actually, my topic of presentation, you can see there, it's satellite activities at the Australian Bureau of Meteorology, but it's actually not really my presentation. Dr. Agnes Lane, who's a Bureau colleague, actually more senior position than mine, who's been a real guiding light in terms of my own satellite meteorology development, unfortunately couldn't turn up for this session, and Agnes kindly asked me, or I was privileged to be able to present on her behalf. So there is information in this presentation that I won't be able to answer, but if you do have questions that I cannot answer pertaining to this presentation, please let me know, and I'll be able to pass that on to the relevant staff members, because it is, after all, satellite activities at the Australian Bureau of Meteorology. So what I'll be focusing on during this presentation, the topics of satellite science activities and some operational products. Now, during the training event, I talked about lightning casts. I have one slide that actually shows it adapted over Australia, over the region of Himawari 9. So it's a little preview there. Okay, so satellite science activities. This particular slide is a little bit of a summary of the satellite science team that is in the Science Innovation Group. So this is the lead team for remote sensing science, new satellite products, and advice on data formats. The team also engages nationally and internationally with Earth observation scientists. The team is responsible for the development of all satellite products for operational use, including national scale cloud and precipitation products, solar radiation, for the energy sector, and vegetation and curing products used for fire weather services. So in the following slides, I will show some of the recent work conducted by satellite science team members. Keep in mind, I'm not really an expert on those. I have received a background on this information, but if you have specific questions that I cannot answer, I'm happy to forward those to the relevant experts. This work is by Naidul Samrat, and it's looking at the impact of assimilating clear sky radiances into the Bureau's regional numerical weather prediction model. Now, see how this goes. Yep, okay. So the top right-hand side are the, I'll just annotate directions. This one isn't quite strong enough. The top right-hand side are the results of a spatial correlation study showing good horizontal correlation at 70 kilometers. You can see that as the dotted line, vertical line. There, the fraction skill score plot on the bottom right shows generally neutral results when the forecast is compared with the global precipitation mission data, but there are small incremental improvements. So each one of those little triangles in the bottom right-hand side on the horizontal axis is the forecast time, and the vertical axis is the precipitation. So whenever that little triangle has a dark black boundary, it's starting to be significant. Most of those triangles don't have a dark boundary. And finally, looking at the left-hand side, Nahidul has tested a simulation of Himawari channel 10, which is the temperature sensitive. And so the results show that there's more bias over land, which is the top one, having a larger scale from 0 to 2, and the bottom one over sea, 0 to 1. So there's a larger bias over land. Ongoing work will look at controlling the bias over land to ultimately improve precipitation forecasts over land. This one here, this is work by Andy Smith, is looking at the diurnal biases in the regional numerical weather prediction system. So if you look at the central one, this is Andy has found that the high resolution model over Sydney, which is the result you see in the central graph, it has smaller biases than the regional models, which are the axis A at the top and the more regional, the global one down the bottom. So the next step will be to redesign the bias correction scheme to reduce biases in the regional model. This is work by Chris Griffin, looks at the impact of the Bureau's developed atmospheric motion vectors on two city models, Sydney on the left-hand side and Darwin on the right-hand side. The objective is to improve the Bureau's atmospheric motion vectors into convective scale NWP so that they improve the forecast, so very high resolution NWP. Chris has produced AMVs using the NWC-SAF software. The results show significant improvements when using these observations for Darwin. Notice the large triangles that have a dark background in that T+0 forecast right across different rainfall amounts, but not so much over the Sydney area. So the next work will be to further optimize the atmospheric motion vectors before inclusion into the regional model. This slide describes the data denial study led by Fiona Smith. All satellite observations were removed from the Darwin city model, and you can see Darwin at the top on the left-hand side, the domain of that over Northern Australia, and the Darwin domains at the top right-hand side, the results for forecasts and the precipitation there on the y-axis. And for Sydney, which is down on the southeastern coast, with the results in the bottom right. And so one of the results is that there is a strong impact when the satellite data was removed, especially for the first sort of 18 hours. Look at the huge purple triangles all going down, decreasing the ability of the NWP to correctly predict. There are some unexplained impacts after 18 hours, particularly for the Sydney model, and that require further investigation. These next two slides are work by Dr. Pallavi Goveka. The Bureau is producing Himawari 9 level 2 sea surface temperature products every 10 minutes with a newly developed method built in collaboration with the University of Reading. Composite level 3 sea surface temperature products further are constructed for the 1 hour. You can see that down the bottom bottom left-hand diagram, for the +4 hour and at the night periods. And you can see that in the 3 rows down the bottom. The improved sea surface temperature products are expected to be better input into the Bureau's ocean models and will help inform operational decision-making, assessment and prioritization of marine ecosystems at risk of thermal stress. Dr. Goveka is currently working on a new geopolar multisensory L3S sea surface temperature product. This includes data from both polar orbiting satellites and Himawari 9 to evaluate sea surface temperatures. Adding Himawari data to the composite sea surface temperature product actually results in at least 20% more data coverage over the oceans. So a real advantage. So data from this, the Bureau is developing marine heat wave products using geopolar multisensory sea surface temperature. So using AVHRR, VIIRS, and AHI. The metrics will cover the whole of the Australian coastal region, so that's currently still under development. You can, in these slides, see the sea surface temperature, top left-hand side, sea surface temperature anomalies down the bottom left-hand side, degree heating days, which is the top right-hand side, degree heating days count, bottom right-hand side. This is a slide that is a little bit close to my heart. They're all good slides, high quality, but sometimes something just rings. It's actually one of two slides. Here's an exciting new development that was stimulated through international collaboration between the Australian VLab Centre of Excellence and Noah Sims, University of Wisconsin-Madison colleagues over the past year. Prob Severe Lightning is a GOES advanced baseline imager, machine imager, ABI-based. Say that again. Slow down, Bodo. Prob Severe Lightning Cast is a GOES advanced baseline imager-based machine learning model. The model predicts where the geostationary lightning mapper on GOES 18 will observe lightning up to 60 minutes in advance based on cloud patterns, or cloud pattern configurations, amongst other things. Leo Majewski, the team leader of satellite science within the Bureau's Science and Innovation Group, has been investigating this data. You can see here He's actually downloaded the code, which Scott Lindstrom has advertised via a VLab session as well. And he's presented probability contours of lightning occurring over the next hour of an area over southwestern Australia. Because Himawari 9 does not have a geostationary lightning mapper, therefore weather zone lightning data is used instead, and that's shown as the dark red dots. So if you're interested in adapting lightning casts, which is of course developed in the US, to Himawari 9, I can forward you the VLab presentation that shows where to find the code. And if you want more information, get in touch with me and I'll talk to Leon about it for your countries over the Himawari 9 domain. Let's have a look quickly. I have 3 more slides, and they are to do with operational products. So, rapid scan images from Himawari 9, we've had that previously introduced by Shimizu-san, available upon request by JMA and available to all registered users and countries. Rapid scan imagery is also available for KMA and CMA. The Himawari request rapid scan data has been applied to a number of locations within the Australia-Pacific region. You can see the large fires off the Queensland coast there. Feedback from forecasters on the value of rapid scan data in monitoring bushfires, volcanic ash events, and thunderstorms has been very positive. It is a valuable resource. One of the volcanoes in the Vac Darwin area of responsibility operating out of Melbourne is Lewotobi in Indonesia. And it's been erupting to low levels since December 2023, but during November, there have been a number of high-level eruptions. The ash moved in multiple directions, impacting local airports and flight paths, and even entering Australian airspace as it dissipated. The bottom right-hand image shows the location of Lewotobi, which is approximately 830 kilometers east of Denpasar, Bali, and Bali is a popular holiday destination, so impact. The top right-hand image is the ground report from CVGHM on the 13th of November at 01 UTC, which showed a strong low-level eruption. And the satellite imagery available at Vac Darwin on the left shows the eruption from Lewotobi at the same time as you see it from the ground there. The event showed how much impact volcano ash can have even at low levels and distances quite far away from the volcano. Finally, there is a growing demand forecasting service to support the renewable energy industry. Surface solar irradiance measurements are based on cloud properties that are retrieved every 10 minutes from Himawari 9 satellite observations and input to a solar model with weather model forecasts and aerosol properties to receive solar radiation at the surface. Cloud properties include type and thickness, and you can see the cloud proper type and thickness down the bottom there. Top are the global solar irradiation and the direct normal irradiance there. And you can see that for the Australian region. And that really concludes delivery of Agnes Lane's presentation. I apologize for reading off the notes a bit, but I'm a stickler for getting the message across correctly, particularly if I'm presenting on somebody else's behalf. Thank you.
I think things that we have to focus on and highlight on how this thing will be Asian countries, that is posing very challenges to us. And I need 1 or 2 quick questions. If you have, okay.
Thank you, Bodo. I have a very 2 quick questions. First is, I saw that your team science team, I mean, is very active in trying to develop or getting the products of the satellite data. So I just wondering whether you are, or what kind of software you're using, I mean, analysis software, whether you are also developing your own software for getting the products, I mean, for deriving the products. And second one is regarding, I forgot the second one, the question. Oh, okay, maybe.
Well, Andy, maybe I'll give you a break by trying to answer your question first. It gives you a chance to think about, well, we do have developed programs in order to be able to process the data through it. If you want more detail, let me know what products you're interested in. And it's kind of useful on an international level, right? Because we had a collaboration with JMA, with KMA, and of course, and KMA colleagues, one came to us during one of the collaboration. Can you help me? How do you ingest Himawari 9 data? And basically, we already developed a code for that we passed on to them, and they said, thanks a lot, that was really helpful. So definitely, if you're interested in any kind of code underlying the examples that I've given, let me know which one, which example, and that goes for all of my colleagues, and I'll be able to pass that back on to the relevant people who are developing.
Thank you so much for this. And I'm now remembering my second questions. I just would like to know, to understand whether you're also using the rapid scan from Himawari for evaluating or analyzing the Lewotobium, sorry, in Indonesia, eruptions.
The monitoring of the Lewotobi eruption in Indonesia using the 2.5-minute data? I believe so. I'll have to double check that.
Okay.
One thing I will say very quickly in passing, JMA are very generous in giving us this rapid scan, the Himawari request. We say thank you in part by developing case studies that we disseminate back to our regional colleagues. And it also acts as a test bed. We sort of do some of the work with JMA in helping to improve their products by using those in local case studies.
So this is very important. I mean, insight from your side. So we thank you very much for your, sharing this information. So that after this, we would like to have more collaboration as well with JMA colleague, KMA, and also CMA. Maybe we can also get the rapid scan for the extreme event like volcanic eruptions, which is very, which is very dangerous for our aviation safety. Thank you very much.
Thank you.
So, announcement, the last certificates is shifted to morning. I think, is it okay? Okay. So tomorrow morning, first we will start with the Dr. Satka's presentation. And now all the poster presenter who has arrived today, they can go to the first floor for announce. Okay, please.
The oral presentation session in both the halls has been very interesting and enlightening. Thank you so much, participants. I would also like to thank Dr. Ellen Huang, ICSC Chair and the Chair of this session, Dr. A.K. Mitra, who is the co-chair, Dr. Shibin, and Mr. Pankaj Kumar, who are rapporteur for this session. Now we have posters presentation session in the first floor exhibition hall. The poster evaluation committee comprises of Dr. Manik Bali of NOAA, Dr. A.K. Mitra, and Mr. R.C. Bhatia. I request everyone to kindly proceed to exhibition hall first, look at the presentations, and then proceed to ground floor for dinner, which will be open at 7 p.m. Also, tomorrow the sessions will start in both the halls at 9:55 a.m. So see you tomorrow. Good night.
So the starting is 4.